What's up, everybody? We're going to be going live here in just about 2 minutes. I want to say thank you all so much for tuning in. What's up, Avery? What's up, Sandeep? What's up, everybody? We're going to be going live here in just about 2 minutes. I want to say thank you all so much for tuning in. What's up, Avery? What's up, Sandeep? Got a nice echo going through there on my monitoring system. All right, the timer has reached 0. I think we are ready to go live. Let's get this off of here. What's up, everybody? Welcome, welcome. Thank you all so much for joining us this morning on TooTallToby's Beginners Surfacing live presentation. We're gonna be talking today all about the wonderful world of SolidWorks surfacing. This is actually a little something that I made for SolidWorks surfacing. You can see it, the little webcam cover. I think this is very important to have this handy in today's day and age when we're all working remotely and often participating in web meetings. You don't want to forget if your webcam is on or off, and so I like having physical devices to help remind me of important things like that. It's great to see everybody in the chat here this morning. If you don't mind, let me know if the audio is all good. Just give me a 1 if the audio is good. Give me a 0 if it's bad, and we'll try to fix it. Today we're going to be talking about the wonderful world of surfacing, and as I mentioned a moment ago, this is a little surfacing project I did a few weeks ago, and maybe this is something we can talk about after we get through today's presentation, after we get kind of the basics down. But today is going to be very much for beginners. You can see that it's called Beginners Surfacing Live. So clearly the target audience for today's presentation is beginning. It's awesome to see everybody here from all over the world. We got people here from Newfoundland. We got people here from India. We got people here from all over the world. Let me just real quick set my phone to D&D. I just want to make sure that I don't get any messages so we can really just focus on one another. I want to make sure that I'm here for you today. All right, let's get into it. So today we're going to talk about surfacing. This is another model I did with surfacing. It's not the model that we're going to go over today, but it just goes to show that surfacing could really be used in a number of different projects, even projects that maybe you think of as being, a little bit more on the mechanical side, like this model here of the skateboard itself. This is a 7-ply skateboard, 7-ply maple deck, and the way that we could go about approaching a model like this could be with surfacing. And it's not actually that hard. I think probably after today, if you understand these basic concepts that we're going to be reviewing today, you'll be able to mock up something like this, or at least kind of get into the ballpark of mocking up something like this. So it's not super difficult to create geometry like this. This is not a super difficult model, but it's all about just understanding those basics, and we're going to go through and talk about some of those basics. We're also going to take a look at another model that's part of this particular assembly, and that is this truck here. And we're going to take a look at this example of what happens when you import a model and the model doesn't come in watertight, when you have a bad surface when you're doing an import command. What can you do to kind of clean that up? So we're going to talk a little bit about that today too. But maybe, if you guys like this particular data set, if you like this skateboard assembly, let me know. Let me know down in the comments if you're watching the recording, or let me know in the chat if you're watching live. And we'll take a look at maybe doing a tutorial on how to put together a skateboard. There's lots of good lessons in there on different things that you can do in SolidWorks when you're putting together really any assembly, but an assembly like this for sure. You've got mechanical side of things, you've got kind of designing for manufacturing, you've got surface modeling, all kinds of cool stuff. All right, cool. Well, let's get into it here. I'm going to just jump into a PowerPoint just to kind of guide us through today's presentation. Today is Saturday, May 16th. We're doing beginner surfacing for beginners. We're starting here right around 9 o'clock, and we're going to probably finish around 11 o'clock. It'll probably run about 2 hours. I'm factoring in taking questions there. So, if there's any questions along the way, feel free to put them in the chat, and I'll be keeping an eye on the chat. Shout out to Eric. Thank you so much, Eric, for all the love on social media and helping me broadcast this out. Shout out to Shyam. He's the person who helped me understand that this would be a good time slot, especially for our friends in India, to make sure that they had a chance to watch this live and to ask questions live. But really for anybody over across the sea from me, I'm on the East Coast, United States. So I hope that you feel like this is a good time for you to do these kinds of live streams. Maybe we can do one in the future sometime. For me, it's Saturday morning. It's beautiful and sunny out. So once we're done with today's presentation, I'm going to be going outside and probably doing some work all afternoon. All right, let's get into beginner surfacing for beginners. This is a presentation that I've given a few times in the past, and I have modified it over the years, try to come up with the best possible flow for this presentation. We start out with a quick intro, we get into some goals, some basics, and then we're going to jump into this mouse example and show you how you can get started creating a model like this using what you've learned earlier. At the end, if you guys have any additional questions, I'm happy to answer them live. Beginner surfacing for beginners. So this is, like I said, it's a presentation that I've delivered a number of times to help people get up and running with surfacing. We're going to start out with a quick intro, just a little bit about myself. I started out my SolidWorks journey back in 1998. I started working for a reseller in 2001, and I started doing a lot of tech support and training. So some of the skills that I've learned are skills that I've kind of developed over the years, but I've tried to provide you with some of these skills in the form of various tech tips and videos. So if you haven't had a chance yet, take a look at my YouTube channel. There's lots of good tech tips on there. Something I really was trying to do to help people who maybe are dusting off their old SolidWorks skills for the first time in a long time with this current situation that we're all in. So if you have a chance, take a look at some of those videos. Lots of good tips and tricks on there, power moves, and we're going to be going through and using some of these power moves today, like understanding how you can shortcut end conditions, or using right mouse button to finish a command, or even using some of the sketch mirror functionality that I talked about in one of those videos. So these skills, these tips, these tricks, these are kind of like a culmination of different skills that I've learned over the years, but hopefully I'm going to present them to you in a way that it makes surfacing really easy to approach. I also want to give a shout out to Andrew Lowe. I would consider Andrew Lowe kind of a surfacing master, and I've attended a number of his presentations. A lot of times in these beginners presentations, I get the question of, what can I do to learn more? Where do I go next from here? This is a beginner's presentation. Are there any advanced presentations out there? And if you take a look at Andrew Lowe, he's got a YouTube channel. He's got lots of blog content out there. He will explain some higher level concepts that we're not going to get into today. So I'm going to kind of help you get through the front door, the introduction, and Andrew's content can help take you kind of to the next level when it comes to surface modeling. I'm actually honored to be able to speak with him live on Monday, May 25th. So on the live stream that I do on Monday nights, Andrew's going to be my guest coming out on Monday, May 25th. So if you want to tune in and hear a little bit more about some of the work that he's done, be sure to tune into that live stream or watch the recording. And if you want to learn more about the wonderful world of surfacing, this is a great next step. Obviously, the target audience for today is beginners. I've said that a number of times. That's if you're just getting started, if you have no experience with surfacing, or even if you have no experience with SolidWorks, you're in the right place. And so I want to just say thank you all so much. Thank you so much to the chat. Vishank is saying that this is perfect. The timing is perfect, so that's awesome. Thank you very much for that feedback, Vishank. And Current Peak RC says this is a good time in Europe as well. Awesome. Thanks a lot, Current Peak. And Rashab says, loves power moves. Yeah, I love seeing your comments in there, Rashab. Thank you so much for tuning into it. And glad to hear that this is a good time. And Shyam says this is cool too. All right, awesome. Let's get into it. If you have questions, just dump them into the chat. I'll be taking a look at the chat throughout the presentation. So I am a habitual note taker. In fact, I've got a notebook right here where I take notes. I've got notes that I take all the time. Anytime I get questions, anytime I learn something cool, anytime I learn something new, I try to take some notes about that topic. Oh, I'm going to take off this sweatshirt. We're all friends here. It's all comfy here. Let's get comfortable here on this Saturday morning. So yeah, I'm a habitual note taker. I love taking notes. So if I was going to take notes, if I was out in the crowd, if I was in the presentation, the screens that come up that have this kind of green background, these screens represents the notes that I would take. So if you're taking notes, if you're like me, if you love taking notes, this is a representation of what my notes would look like. So I would start out here with notes that say, we're going to start out by going over a couple of primers. And when it comes to these primers are things that I like to do to kind of set the stage for the rest of the presentation. We're only 10 minutes into the presentation, and what I want to do is make sure that you guys have lots of good tips and tricks and some things you can use right away, even if you had to jump out of the presentation right now. So the first of those primers is that when it comes to surfacing, you can actually use a surface as a plane. And where this is really handy is when love. Sorry, I just read Varen's note here. It says, even I love taking notes. That's awesome, Varen. So you know exactly where you want the plane to be. This is a situation where you know exactly where you want the plane to be, but sometimes creating that plane in traditional SolidWorks is a little bit difficult. For example, here you can see we need a plane that's over by 4 inches and going up at a 30-degree angle. Okay, let's create that in SolidWorks. So we jump in here to SolidWorks. We go to a part file. Our part file here is going to be this guy. And we're going to create a plane that needs to be over by 4 inches and needs to be at a 30-degree angle. How do you even do that in SolidWorks? I mean, maybe you could start with this face here. You could go to reference geometry plane. You could offset that over by 4 inches. Okay, now you need to get another plane at 30 degrees. How do you do that? I guess what you could do is you could create a center line here. And then after you create that center line, you could exit that sketch. And then you could go reference geometry plane. And you could pick this plane and pick this center line. And then SolidWorks is going to give you a new plane that's perpendicular to the original. That's not what you want. So maybe you want that to be at an angle. And what's the angle? The angle's 30. And let's see here. Okay, that's not quite right. So I guess we actually want that at 60. And if we make it 60, yeah, I guess that's right. It's not really in the right spot, but I guess it's right. I guess I could just extend the surface plane. The point that I'm trying to make here is that even with a simple example like this, it sometimes feels like you have to go through a lot of steps in order to get the surface, the planar location to be just where you want it. So what we can do instead is we can just lay out that information in a sketch. So I could go here to the front plane, I can begin a sketch, I can orient my view, and I can go here to the line command, let's say, and I'll make a line that comes over by 4 inches, and then I'll make a line that comes up at an angle, and then I'll say that I want that line at the angle to be at 30 degrees. That to me seems a lot easier. It seems like it's a lot more intuitive than what we did a moment ago. I'll take this lower line here and make it for construction so it's not used in the feature. And then what I'm going to do is I'm going to go to my surfacing toolbar. Now, if you don't have this toolbar, you'll have to turn it on. It's in the software for all SolidWorks users, but it's not necessarily turned on. So I'll go here to my surfacing toolbar. And once I go to my surfacing toolbar, we've got a command here called extrude. Now, when it comes to extruded surface, the extruded surface command is a lot like your regular boss extrusion command. Like you'll notice here that if I go to extrude this, I can drag this arrow out, and I've got my end conditions here like blind and through all and up to next. This looks a lot like your regular SolidWorks extrusion command. And that should be reassuring. You should know that, these tools are not going to feel like they're foreign tools. They're going to feel, pretty standard. So I'm going to hit the green check mark here, and you can see that that creates a new surface. A new surface. Now this surface has no thickness. It has no mass. It's theoretic, right? Everything has thickness. Even a piece of paper you can measure the thickness of. But this surface has no thickness because it's a theoretic entity. what I'm going to be using this surface for is I'm using it as a form of construction, just like we would use a plane. So you notice here's the surface. It's going to work for me just like a sketch plane. So I'm going to pick the surface, begin a sketch, orient my view. I'm going to create some geometry here. I'm going to create those little pegs that we saw in the PowerPoint slide. So I'll make that 1 inch in diameter. I'll create a center line here that comes across like so. I'll do a mirror here, mirror entities, and then I'll create a distance dimension between these two. So I'll make that at say 4.5, and I'll create a dimension maybe from the location of the start of that plane up, or wherever these things need to be located. So we'll make that 1.75. Gotta fully define your sketches every time, guys. All right, I wrote a song about that once. Fully define your sketches every time. It's on my YouTube channel. All right, so now what I'm going to do is I'm going to take that geometry and I'm going to go to the extrude command, and then I'm going to double click on this face here, which is a shortcut to end my extrusion. Then I'm going to right click to finish that command. These are some of the shortcut videos that I've made in Power Moves. So if you want to learn some of these great time-saving tips, be sure to check out those Power Moves videos. But more to the point of today's conversation, what do we do with that extra surface now? Well, you can just hide that surface when you're done with it. It's just like a plane. It's just reference geometry. In fact, a lot of times I tell people we don't use surfaces as our final feature. We don't just stop and hand off a model with a bunch of surfaces. Just like you wouldn't make a bunch of planes and then hand off a model with a bunch of planes to somebody else. It wouldn't really make much sense. So you don't really typically hand off a model with a bunch of surfaces. Instead, what you do is you use those surfaces for construction or as reference geometry. In fact, if I go to the command File, Make Drawing from Part, and I go here to make a new drawing from this model, when I drag in this drawing view, you can see that the surface doesn't show up. So in the chat, if this has ever happened to you, give me a 1 in the chat. If you've ever been in a spot where you've gone to make a drawing, maybe it's a drawing of an assembly, and some of the parts don't show up, and you're wondering why. So if that's happened to you, just give me a 1 in the chat. What's up, Joe? Welcome to the chat. Welcome to the live stream. So this is something pretty common that can happen to people. You go to make a drawing, you bring in a model, maybe you downloaded that model, maybe you downloaded an assembly, and for some reason, some of the parts that are in that assembly or some of the elements of that model don't seem to show up in your drawing. Well, the reason why is almost always because those elements are surfaces. And if you've got surfaces in your design, SOLIDWORKS thinks that those surfaces are actually what's called reference geometry. All right, and so I'm seeing in the chat here, you can see here, Varms has had this issue, Shyam has had this issue, PJ has had this issue. Why do we have this issue? Because we don't typically hand off a model with a bunch of surfaces to somebody. We typically use surfaces as reference geometry. In fact, you can go in here to the command Insert Model Items. This is where you would go to bring in dimensions from your models or other elements from your models. And down here at the bottom of your model items, there's this section that says surfaces. And what is this in? It's in the category of reference geometry. So if you have axes in your model, you're using those axes to create a SOLIDWORKS model. They're reference geometry. You could bring those axes into your drawing. Well, same thing here with the use of surfaces. Surfaces are reference geometry, so you can bring these surfaces into your drawing by going to the command Insert Model Items, then coming down here and choosing Surfaces. And there we go. There's that surface now. It's showing up. So we've learned a couple of key ideas here. Number one is that it's a lot of times easier just to draw a line, and take that line and extrude it as a surface and use that as a sketch plane. It's very, very intuitive. You know right where you want that plane to be. And this is something right here I use all the time. It's just easier. I know right where I want the plane to be. I know exactly what angle I want it to be. You can also see here that we talked about a little bit of a bonus tip. And we also discussed a key concept. Surfaces are reference geometry. They're theoretic in nature. They have no mass, they have no volume. They should be treated in your mind kind of like planes and axes. They're used to help construct the model, just like we use the surface here to help construct the model. But you're not using the surface as your final handoff to the next stage of manufacturing. And we talked about a little bonus tip. You can go into the command Insert Model Items, and that'll let you bring those surfaces into a drawing. All right, let's talk about one more of these kind of quick primers. These primers are they didn't really fit maybe anywhere else in the presentation, and they're a good way to get the ball rolling. Another way that you can use surfacing, even if you're an absolute beginner, is you can use surfacing to help with flattening a difficult sheet metal design. This is an example that came from a question I got in tech support a long time ago. Not this model, but just the question in general. The question was, how come I can't create a sheet metal roll of a cone and then throw some tabs up on the top and then flatten it? And it's a great question. And ultimately the reason why is because of trying to create a flange on a curve. It's often problematic. When we're in sheet metal, it's often problematic to create a flange like this that's on a curved edge. But we can do it in SolidWorks pretty easily. You know, you can see here that we could create a lofted shape. So just two sketches lofted together. We could create some cut relief for one of these tabs, a little bit of cut relief there. And then we can create just a boss extrusion with the same wall thickness, maybe a little slot there for that hole. And then we can create a couple of fillets. Well, SolidWorks has a really handy tool if you're a SolidWorks premium user. And that tool is called Flatten Surface. It lets you take any surface and it lets you unfold that surface into a flattened state. It also will show you deformation. So it can be very handy for textile type industry. Like if you're laying out the leather for a shoe, you could have it unfold and then you can actually see what the deformation is going to be. And you can even get some feedback as to whether or not you're going to need to rip that material. But in the case of sheet metal examples like this can be a huge saver to a project. Because otherwise, how are you going to do this in sheet metal, right? You might not have anything else. You might have to go out and maybe purchase a third-party product that'll let you flatten anything. But built right into SolidWorks Premium, we have this tool here called Surface Flatten. So a lot of times what I'll do is I'll start out by doing a right mouse button and then select tangency. That gets all the faces that are tangent to the face that I did a right mouse button on. And now what I want to do is I want to take all those faces and I want to perform a copy command. So I'm going to take all those faces and I'm going to copy those into their exact current location. So that's going to be a command called offset surface. You can see here that right now I'm offsetting it at 0.1. So these surfaces are jumping down 0.1. I'm going to offset that at 0. This basically lets you make a copy of the original geometry. So I'm going to copy that at 0. And now I've got a surface exactly in the location where the solid body was on those outer faces. I'll hide the solid body. Here you can see the surface body. You can see that with a surface body, there's no wall thickness, there's no mass, it's theoretic in nature. You also see a little bit of color coding, like this edge here is black, and that's indicating that these two faces are one single surface body that are connected together at that black edge. And then this edge here is blue. And that's indicating what we call an open surface. It means that the edge of that surface isn't connecting to anything else, to any other faces. So you can see here we've got that kind of blue edge as well. Open surface edge versus a connected or knit surface edge. An edge that's going between two faces in one single surface body. They're connected all along that edge. It's not really what we're talking about right at the moment, but it is important to recognize the difference between those colors. It's a question that I get pretty often. You know, what's the difference, or how can you tell that it's an open edge? That's how you can tell. So this is a surface body. And so now what I'm going to do is I'm going to take this surface body and I'm going to turn this into a flattened design. So I'm going to say flatten surface. It's a command up here on my SolidWorks surfacing toolbar. Flatten surface. And when I click that flatten surface command, it does kind of work like sheet metal. Like you select your faces to flatten. It kind of reminds me of when we would do insert bends in sheet metal in the old days. So we do a right mouse button here. We say select tangency. I'm going to get all those faces again. And now I'm going to come over here and I'm going to declare which edge or which vertex I am going to hold for this flatten command. So I come over here, I pick in this box here, and now I can choose an edge to hold for this flatten command. Now, the final thing is that we have an option here for accuracy for this surface flatten. And if I don't adjust that, you'll see that those edges which were kind of slotted before, these slotted holes here, just kind of turned into squares. It's kind of weird, right? Why did that happen? Well, what's happening is we're creating a 2D mesh and we're overlaying that 2D mesh on the surface to be flattened. You can see what the 2D mesh looks like here. And you can see graphically, what the result is. The closest fit that I can get for that 2D mesh is not going to be able to encapsulate isolate those circular edges. So all we need to do is just increase the mesh density here by increasing the accuracy. Now you see the mesh is getting a little more dense. We're capturing a little bit more of those circular holes. And this will have an impact on how long the command takes to complete, of course. So it's, nothing's free. So you can see here that if we increase this out a little bit further, we can get a more accurate result. And we can hit the green check mark. And now you can see that the flattened surface has completed. Here you can see the original surface body. We could just hide that. Here you can see the flattened surface, and we can do a right mouse button here and we can say deformation plot. So this is showing us how much the material had to stretch or how much the material had to compress in order to create this flattened view. And we can see that the max compression is 2.5%, and the max tension, the max stretch is 1.223%. And that is well within the spec of this material. This material can stretch up to 8%. So it's well within the spec of this material. Therefore, I'm going to push this through. I'm going to turn this into a drawing, and I'm going to let the sheet metal team take a look at this. Now, the thing is, a moment ago, we talked about the idea that you can't really show a drawing of a surface body. So what would we do from here? What I would probably do is I would probably go back and look at what the wall thickness was of the original body, and then take that same wall thickness, I think it's 60 thou, and I would apply a thicken command here to the surface body. We're going to talk about thicken in just a little bit, but I would apply that same thickness here, and then I would just have two configurations. Oops, I think I did 900 thou there instead. That's going to be a little bit more difficult to bend those tabs. I did do 90 thou, huh? I got that thing pretty thick. So now you can see here that I would have maybe one configuration where this body is showing and one configuration where this body is showing, and then I could drop that into a drawing. Maybe I would go in and I would examine those slots. You remember before we talked about how they got a little bit deformed. Maybe I would just clean them up a little bit so that the laser cutter will cut them properly as slots, whatever needs to be done. But that is another primer there that you can use the flatten a surface command with SolidWorks surfacing. And you can see here that there's a step-by-step process that you would go through, but you do need to have SolidWorks Premium. So a question came in from Current Peak RC. What is SolidWorks Premium? Yeah, great question. SolidWorks comes in 3 flavors when you purchase it commercially. You get SolidWorks Standard, SolidWorks Professional, SolidWorks Premium. And the flattened surface is only available in the SolidWorks Premium build. If you're Student Edition, I believe you get everything that's in Premium, so you probably have it. Oh yeah, Avery's confirming this, yep. My professional version is showing flattening. Oh, that's interesting. All right, so let's go to... So another thing here, PJ said my professional version is showing flattening. I may need to make a kind of on the fly correction here. So let's go into SolidWorks and just take a look here. So we'll go help, SolidWorks help, and then we'll look at flatten, and we'll say flatten surface here. I don't know, maybe it's possible to change. Full disclosure, this is a 2019 SP5 build. When I'm doing live streams, I like to be on the SP5 build. So I'll have to look in 2020, but a lot of times in the help, it'll tell you which flavor of SolidWorks that feature is included in. So it's possible maybe they moved it in 2020, but I believe it's only in Premium. Okay, Neil is saying his pro version is showing as well. Hey, maybe they moved it. Maybe I'm wrong here. That's awesome to know. I'm going to update my slide and I'll change that information and make sure I'm giving everybody the latest information. Cool. All right, and I'm just taking a look at the chat here. Looks like we can see here Student Edition has everything like Premium. Awesome. I like this deformation stuff. Cool. That's great. Yeah, this is something it's gotten me out of a lot of jams when I couldn't flatten a sheet metal design. This is something that's gotten me out of a lot of jams. Eric's got a little pro tip there in the chat if you guys want to read that. I did know about that one. I didn't want to be the one who said it, so I'll let you guys read Eric's comment there, but I love that. That's a little insider trick there that you can get through. What's up, Nuno? Welcome to the chat. What's up, Neil? How you doing? Welcome. Barry saying his pro version has a grayed out. Yeah, that's what I would have thought too. I would have thought the pro version would have had it grayed out. Listen, guys, I'm really happy to be here with all you. I think this is awesome, and I want you to know that I am kind of taking my time going through this presentation. I gave this presentation a couple of weeks ago, and I messed up the time. I misunderstood what my time slot was going to be, and it was a little more compressed than I expected. And so I like to give this presentation a little bit of room to breathe. If you like this speed that I'm going at, let me know in the chat. Give me a 1 in the chat if this works for you. I know that we haven't even really gotten into our official surfacing tips and tricks yet. We've shown a couple of quick primers here, but let me know if you guys are okay with this pace. If you want me to speed things up a little bit, I definitely can. But I feel like this is such a cool topic, and it's definitely worth kind of easing into it a little bit and sharing these tips in a way that everybody can understand, even if you're brand new to SolidWorks. I did kind of manage out the time slot for 2 hours, which should give us plenty of time if we continue at this pace. But just let me know if you guys are okay with this, because I don't like rushing through presentations. I like just kind of making sure every question is answered, making sure that, like I said, I like to let the presentation breathe like a fine wine. So, okay, awesome. I'm seeing some 1s in the chat. Thank you all so much. Thanks, Avery. Thanks, PJ. If this is too slow, if you want me to speed it up, put a 9 in the chat, so you know, and I'll know that we got to turn it up a little bit. What's up, Stefan? Thanks for tuning in. Welcome, welcome. Half page of notes already. Awesome, Avery. Appreciate that feedback. That is awesome. Okay, cool. Cool. Okay, awesome. And thank you, Eric. Awesome feedback. Thank you so much for answering all these questions. Lots of great questions that we got coming in here in the chat. Okay, well then with that, let's keep going here. Let's talk a little bit more about the wonderful world of surface modeling. This is what my notes would look like so far, talking a little bit about how you could use a surface as a plane, talking a little bit about how you can use flattened surface. We haven't even gotten into beginner surfacing, so let's move on now to the second part of the presentation, where we're going to talk about the goals of the presentation. Oh, hey, what's up, Tambora Station? Hey, thanks for tuning in. All right, appreciate that comment too. Glad to hear the pace is good. All right, and what's up, Milton? Thanks for tuning in. And Sandeep says, we need to turn it up to 9. We need to move this thing along. Okay, so Sandeep, I apologize. I think you're getting overruled by the majority, but I do appreciate the feedback, and maybe I'll just adjust it a tiny little bit on my potentiometer. All right, so let's talk about the goals of this presentation. The goal of this presentation is to remove the fear of surfacing. If you receive a surface model, a lot of us, when we're first getting started in SolidWorks, we have this attitude of like, I don't do surfacing. No. That's I've never learned those tools. I never learned how to do that. That's not for me. And I don't want you to feel like that. At the end of this presentation, I hope that you don't feel like that. And the way that we're going to approach this is by showing you some of the basic tools in surfacing and showing you that the ones that are in green here are pretty much the same as what you would expect from the solid equivocal. So for example, the extrude surface that we looked at earlier, it's got the same end conditions, it's got the same like up to vertex, it basically follows the same rules. It's the same way of creating that geometry. And then there's maybe just a set of 4, or maybe I would add a 5th one here with knit surface, key tools that are going to really get you through a lot of the first challenges you'll run into in the world of surfacing. So once you get through these, 4 or 5 key tools, once we go through and look at them and explain how they work, you're going to be able to really just start flying and start using surfacing to create your models. So we're going to try and take away some of the mystery, which is going to help to take away the fear of surfacing. A lot of times what I like to say is the goal, I like to refer to this famous quote here, which is the goal is to take all of the fear away by taking the mystery out of how, and more importantly, why surfacing is an essential tool for all SolidWorks users. You notice that I put that in quotes there, but that's just a quote that I wrote, Toby Schnars, last night when I was putting this presentation together. So this is just a little quote that I like to share with people. This is our main goal for the presentation. We're gonna take all of the fear away by taking the mystery out of how, and more importantly, why surfacing is important. When do you use it? This should be a tool just like fillets or planes. It should just be another tool that you have in your tool chest. It doesn't mean you're exclusively modeling with surfaces. It means when you run into a weird spot, you can just pull out that surfacing tool chest and you can start fixing that issue there. It reminds me of like my soldering tool chest. Like I don't use my soldering tool chest all the time, but it's good to know that I've got it. It's good to know that if I run into a jam, I can pull out that toolkit and I can start using it to fix that jam. All right, let's get into our next section here. Basics of surfacing. So I like to break down the basics of surfacing into these key points. Number 1, every solid that you work on is actually a group of surfaces. Believe it or not, you can delete a face off of any solid and you can turn it into a surface model. So you're already working with surfaces. It's awesome. You're ahead of the game. You're further ahead than you thought you were. Number 2, surfaces have no thickness and have no volume. Okay, surfaces are theoretic in nature. They have no mass. They're not going to affect your mass properties. They should be considered reference geometry. You don't hand off a model with a bunch of surfaces to the next person downstream, at least not usually. Usually what you do is you use those surfaces to come up with a solid design, and you hand off that solid design to the next person. Number D. Surfaces allow you to create one face at a time, where solids force you to create all faces at once. Now, this is getting a little bit into the why, or when. When should I use surfaces? You know, a lot of times when you look at a model that's created by somebody who's got some experience, it looks like it's a crazy, swoopy, lofty model, like maybe the lid here of this bottle. You can see that the way that this model started was with solids. So this very first feature here, this revolve of the lower section, should I make that as a surface or should I make it as a solid? I'm just going to make it as a solid, right? It's easy to make. It's easy for me to visualize. It's easy for me to make that as a solid, and maybe make the cut revolve that's on the bottom here as a solid. Yeah, that's a solid feature as well. And then I can start getting into creating one face at a time. Because when I make that lofty shape across the top, I don't want to make it all at once. I want to kind of hack and slash different surfaces together. Hack and slash these different surfaces together. This surface here, you know, like all these different surfaces are starting to come together, and we're going to merge them together, and we're going to hack and slash them together. But ultimately, you know, we're looking for situations where we can use one face at a time. So you notice I'm making this curved region here, one face at a time. I'm making this curved region here, the lid, one face at a time. I'm making these flat faces here, one face at a time. You know, we do one face at a time, and then what we do is we use those different faces to trim one another, to cut one another, and then we're able to thicken all those faces together, knit all those faces together, and then thicken all those faces into one single solid feature. So now at this point, when you see this thicken command in the tree, at least for me, when we see that thicken command in the tree, 1 second, let me just hide this body. What that thicken command means is that now we're back to a solid. And so now what do we do after the solid? Well, we'll throw a hole through here. Is that going to be a surface? No, it's a solid feature. It makes way more sense to do that as a solid. And then these remaining features here, these fillets and chamfers, are they surface features? No, they're solid features. It just makes more sense to do that as solid features. So understanding when should I make it as a solid? When should I make it as a surface? Well, one of the key answers to that is, will it be easier for me to make this one face at a time? Because if it is easier to make it one face at a time, then you should probably do it as a surface. And now finally, surfaces and curves are partners. So splines, 3D sketches, fit splines, projected curves. These are all tools that will go hand in hand with your surfacing journey. So if you're going to learn a lot about surfacing, start looking at videos, start looking at tips and tricks on how to use splines better, how to use 3D sketch, how to use fit spline. What is fit spline? How do we use that? How do we do projected curves? These are really, really important tools that all, hardcore surfacing users are familiar with. Because a lot of times what you do is you create a framework with curves and then you lay those surfaces over top. It's kind of like a paper mache almost. So you're going to need to create that framework first, and you do that using your curves, using your tools with curves. All right, what's up? What's up, Matthew? All right, thanks for tuning in. I know you can only drop in for a minute, but it's good seeing you in here. Eric Beatty says, one face at a time, isn't that? It sounds like it should be. Yeah, one face at a time. Maybe a TooTallToby song. Vishank co-signing on projected curves. Yes, indeed, they are awesome. You guys are going to see some projected curves later in this presentation. So basics of surfacing, every solid is actually a group of surface. What we're going to do here, if you want to take notes, if you're taking notes, you should probably just write down these key points, because what I'm going to do is I'm going to go through each of these key points now. Some of them I'm going to spend a lot of time on. Some of them I don't really need to. Like surfaces have no thickness, have no volume. That's a really important concept to understand, but I don't need to show it. Like I've already shown it a number of times. We're going to kind of blast through that one. So we're going to now go through and we're going to take a look at some of these concepts one by one. And one of these concepts is that surfaces, every solid is actually a group of surfaces. So let's take a look at this example of a very simple cylinder. We're going to go new. We're going to go part in millimeters. We're going to go top plane, begin a sketch, orient our view. We're going to create a circle here right on the origin. We're going to take this circle and we're going to give it a diameter here of 30 millimeters. And wait, hold on a second. I'm going to flip this over real quick. There we go. Let's try this again. We'll go new. We'll go part in millimeters. We'll go here to top plane, begin a sketch, orient the view, S key, jump into the circle command here, bring that off, make that 30, S key, jump into the extrude command here, and we'll make that 30 millimeters high. This is a solid. If we take a section view of this thing here, you can see that what we're looking at here is solid geometry. So this is a solid model. All we did was a regular extrusion there. Now we're going to basically do the same thing again, but this time we're going to do it using a surface. So top plane, begin a sketch, orient the view, make this guy 30 millimeters over. We'll just create a horizontal relationship here, and then we will create a dimension here that goes between these two. We'll make that dimension, say, 60 millimeters. Nice, fully defined sketch. Got to fully define every time. Now we're going to go to our surfacing toolbar. So again, I've turned that on, turn on the surfacing toolbar, and the first command that's in the surfacing toolbar is extruded surface. And you can see over here our end condition, through all, up to vertex, up to surface, up to body. It's all the same as what you would see if you were doing a regular solid extrusion. Go in direction 2 if you want. The difference is that this surface, you notice here it says cap end. It's not going to have any of the solid material that's in this original model here. So if I hit the green check mark, you can see, look at that, we can see right through that surface. We don't have any of that solid material that we had in the other one. If we do a section view here, you can see this one is solid, this one is a surface. So we don't have any of that solid material on the inside. This one is theoretic in nature. I'm not picking the inside of this face or the outside of this face. It's just one face. There's no thickness. So it's a completely theoretic entity. So how do we go from this to this? Well, the way that we get there is we use a command called thicken. So here's the command called thicken. And when we choose the thicken command, what we're doing basically is, well, let me just create it here and I'll ask you guys in the chat. What does this look like? What is the solid equivalent of this command? What do you do when you're solid modeling that gives you a result like this, where you can see that we've now turned this into a solid? We input a wall thickness, right? When we were creating this thicken, what's the solid command that looks just like this? So you can see here that now we have this this thickness here at 2 millimeters. We hit the green check mark and you can see here what this ends up looking like. I'm going to let that answer come in on the chat, but I'm going to keep moving forward here. So what is the solid command that looks like thicken? Ultimately though, the direction I'm going in with this is that if we go to the thicken command, we can take a theoretic surface body that has no thickness, we can apply a wall thickness to it, say 3 millimeters here, and now you can see that this thing is a solid. Yep, and you guys got it. Avery, you got it. You're spot on. And Rishab, you got it. That's right. And Sandeep and Cheyenne, you guys all got it. All right, awesome. So yes, that's absolutely right. If we click on a solid and we go to the feature command shell, you can see that what's happening here is we can input a wall thickness, we can indicate the face that we're getting rid of, we can hit the green check mark, and there we go. SolidWorks shelled that out. Now, what's actually happening in the background is pretty cool, and I'll show you an example of that at the end, what's actually happening in the background, how it's using surfaces. But that's exactly right, and I want you to recognize that because it makes it a lot easier to approach this idea of surfacing. You know, I wouldn't hand somebody off this surface. I would create the surface, and then I would thicken it. So in order to get to the shape that we're looking at here, we have to create the additional faces. We create our faces one face at a time. So I'm going to go here to the top plane now, and I'm going to create a sketch, and that's going to be a sketch of a rectangle, and I'm not going to fully define this sketch. I'm going to break my cardinal rule here. And I'm just going to create a rectangle that kind of caps off that edge. And listen, in the wonderful world of surfacing, a lot of times you don't fully define your sketches. A lot of times you're just trying to get something out the door that you can 3D print that feels good when somebody puts it into their hand. And fully defining sketches, you know, like any tool, it can be a little prohibitive. You know, like If you're putting a nut onto a hex bolt, do you always tighten it all the way down? Not necessarily. It depends on what you're trying to accomplish with that nut. And it's the same thing here. Most of the time, yeah, you fully constrain that nut. You fully tighten down that nut with like a spring washer. But not all the time. There's some spots where you actually want it to be loose for one reason or another. So in this spot, we're going to leave this sketch loose, and we're going to go to another surfacing command. This time, we're going to go to the command called planar surface. Now, when we did the extrude command, what we did was we took our geometry and we brought it up perpendicular to the sketch. So we would take this rectangle and bring it up perpendicular. But that's not what we're doing here. We're going to use the planar surface command, which is going to take the geometry that I selected, the sketch, and it's just going to fill that in with a planar surface. So now we've got a total of 2 surface bodies. Now, another thing that most surfacing, hardcore advanced surfacing pros will do is they'll go into their system options, they'll go here to feature manager, and they'll go to this section here for these folders. How many solid bodies do I have in the tree? How many surface bodies do I have in the tree? So this is going to be where these items are displayed over here in the tree. And when it's set to automatic, that means that sometimes it's hidden, sometimes it's shown, depending on how many bodies you have in the model currently. Most of the time, what surfacing people will do is they'll set both of these to show. Because as you've learned already, we're going to be going back and forth between solids and surfaces. Yes, we are working with surfaces, but we're trying to get to solids. So as a hardcore surfacing user, what I want to do is I want to make sure that I am always keeping track of how many surface bodies do I have and how many solid bodies do I have, because it's very helpful to keep things straight. Like right now, is this 1 surface body or is it 2? It's 2, right? So we're gonna be creating here 2 surface bodies versus, the 1 single solid body. We've got 2 surface bodies. That's very helpful information. Why is that helpful? Because if I go to do the thicken command, I can only pick 1 surface body to thicken. I can't pick both of these. I can only pick 1. So I have to somehow get those 2 surface bodies to become 1. And the way that I'm going to do that is with what's called a knit command. But before I can knit those 2 together, I need the edges to be lined up. This is a question I just saw on Reddit the other day. How come I can't knit these 2 surfaces together? I pick this one, I pick this one. How come I can't knit these together? The edges that are open, the edges that are this blue color, they need to be basically right on top of each other. There can be a little bit of deviation, like let's say like a 1 thou deviation, 1/1000th of an inch, or maybe 0.01 millimeters of deviation between the 2 edges, and SOLIDWORKS can pull them together. But for the most part, the edges need to be right on top of one another. So the way that we're going to get those edges to be on top of one another is we're going to use a command called trim. So I'm going to pick trim here, and the tool that I'm going to use to trim is going to be this surface body, and then I'm going to choose to remove the outside of this rectangular surface body. So I'm not getting rid of what's inside, I'm getting rid of what's outside. And when I hit the green check mark, you can see that now those 2 surfaces are lined up. Those edges are nice and lined up. But if I go to the thicken command, I still can't pick both of these. Still can't pick both of these. I can only pick one. I can thicken the bottom or I can thicken the sides, but not both. Why not? Because I need to knit those 2 surface bodies together. I've got 2 surface bodies here. So you can see here that I'm going to go to the knit surface command. I'm going to pick this body here and this body here. You'll notice that right now we've got a blue edge, that kind of light blue edge between those 2. I'm going to go knit surface. I'm going to pick, I'll do a select other here. I'm going to pick this body. I'm going to pick this body. I'm going to hit the green check mark. And now you can see I've got a black edge there. So those 2 surface bodies were knit together properly, and that means that when I go to the thicken command, I can pick this surface body here. You can see that I can thicken it, and there we go. We've got our thicken, and it thickened the whole thing. We now have a cup instead of just having a cylinder. If we try to do that before the knit command, it would look like this. So I'm going to delete that knit command. I'm going to roll back here. I'm going to go thicken. I'm going to pick this edge here. And you can see that if we tried that again, we would just end up with this. That lower surface is still there, but it's not part of the thicken command. So now what we need to do is create another cap up top here. So we're going to do another cap up top here. This time I'm going to use a different command. I'm going to use what's called filled surface. We're going to talk about this a few times here as we go on. But what filled surface basically lets you do is pick a perimeter, and then it kind of lays a blanket over top of that perimeter. Like if I've got this this napkin here, You can see I've got this napkin here. If I wanted to take this napkin and lay it over top of this glass here, you know, like so, that's kind of what fill surface does. It looks at the open border of the edges that you select, and it just lays a new surface there over top of that open border, fill surface. So I do fill surface there, and now I've got a cap on top, and now I can knit that cap, because you can see I've got these two bodies still. I can knit that cap onto this surface here, and I can hit the green check mark, and now I've got this nice watertight vessel. But you'll notice it's still not a solid. If I go to my section view command, it's one single surface body, but it's still not a solid. And so what I can do is I can choose the thicken command, and now when I go to pick this solid body, when I go to pick this body here, you're gonna see that a new option shows up here. So you'll notice right now there's only the option for merge result, but when I pick this watertight vessel here, you'll notice that a new option shows up that says create solid from enclosed volume. And when we pick that option, create solid from enclosed volume, the thickness goes away. We're no longer applying a wall thickness, and instead what we're doing is we're filling in the entire inside of that model. So now you can see that we've got a solid. So in summary, when you're working with surface models, the workflow often looks like this. You create your geometry one face at a time. That one was for you, Eric. We go here to surfaces, extruded surface, we make that 30. We go to, let's say, the planar surface command. We pick this edge here to fill in a planar surface there. We go to the surface fill command. We pick this edge here to fill in a planar surface down here. We go to thicken that, and we don't see the option for create solid from enclosed volume. That's telling us that our vessel is not watertight. Oh, I forgot to knit. So I'm gonna go knit here. I'm gonna knit all these surfaces together. I'm gonna hit the green check mark. Now I'm gonna do thicken again, and I'm gonna pick that, what I hope is a watertight vessel. And when I do, this option shows up that says create solid from enclosed volume. I can hit the green check mark, and now you can see that we've got 2 solid bodies in our tree, and we've got 0 surface bodies in our tray. And that step-by-step process of make one face, make another face, make another face, knit them together, solidify them, that is probably 95% of surface modeling right there. That is the workflow. That's how you get going with surfacing, and that's how you create like a weird little area just in one region of your model. Now, I mentioned at the beginning that every time you work with a solid, you're actually working with surfaces. You can pick this face here of a solid, and you can come up here to where it says delete face on your surfacing toolbar. And when you choose delete face, if you just choose this option here, delete, and you hit the green check mark, you can see that now in the tree I've got 1 surface body and 1 solid body. So anytime you have a solid body in your design, you can turn it into a surface just by deleting 1 face. So you can see here now this is a surface model, and now maybe what I want to do is, instead of doing a fill like I did before, I'm going to go here to the front plane, begin a sketch, and I'm going to create a little thingy here, like a little thingy here, a spline, little bit curvature there. And now I'm going to say, when I go to create that fill surface, I want to lay that fill surface over top of this spline. So I don't want to just lay it on the top of the cup. I want to lay it on the top of the cup and have this spline up top. So I go here to filled surface. I choose this edge. I choose down here under constraint curves, I'll choose this little spline here. And now you can see that it's not just going to create a regular fill surface, it's going to create a fill surface that goes up over top of that edge. How cool is this, right? Like, we're in the very beginning of beginner surfacing, and look at this crazy shape that I made. And now how do I get that to be a solid so I can 3D print it? I do knit surface, I knit these two together. Now I've got 1 single surface body here. I go thicken, the option for create solid from enclosed volume shows up. I hit the green check mark, and we can see here now that this is a solid. The other thing that I mentioned to you a moment ago is, what's actually happening with a shell command. Well, with a shell command, essentially what's happening is SOLIDWORKS is taking these faces here. So it's taking these 2 faces, it's going offset surface. So it's going to offset these to 3 millimeters for our shell. We do a reverse direction. So now we've got a surface body. Let me hide this solid body. We've got a surface body in here, which represents that kind of offset in region for the shell. It's capping that end. So we'll do a planar surface here. it's taking that geometry and making sure that it's one single surface body. So now you can see that we've got this surface body here, and we've got this solid body that it's sitting inside of, and then it's taking that surface body and it's performing a thicken cut command where it is removing the geometry from that surface region from your solid. And there's your shell. So when you click shell and SolidWorks just magically works, that's kind of what's happening in the background. And it's good to know, because it means that if you ever have a shell that doesn't work, you might be able to get in there and just offset the surfaces yourself manually. You might be able to figure out which region is failing, exclude that region, and just shell the rest of the model. Or, or some other solution. That's something else that we do a lot when it comes to working with surfacing. So understanding a little bit about the background of how surfacing works and how this workflow goes, it's, obviously it's super helpful. I'm going to go back here just a moment to this point. So here you can see I've got my surface extrusion, and that's it. I'm going to actually just erase everything else in the tree. So we're going to get rid of everything else here. Get rid of everything else in the tree here. And we're going to take a look at our surface extrusion here. Let's get this thing fully defined. Fully defined every time. It's good. No, I'm actually just doing that because I want to make sure it's aligned horizontally. Okay. So now you saw an example of what happens with the shell command, right? What does the shell command do? It creates an enclosed surface volume, and then it removes anything that's solid from that enclosed surface volume. Well, guess what? Cut extrude does the same thing. Cut extrude, when I create a cut extrude here, so I'm going to make this 15 millimeters, and I'm going to go extruded cut. What cut extrude is doing here is, actually, before I ask this question, let me just ask in the chat. Give me a 1 in the chat if you have ever tried to do a cut extrude on a surface and it did not work. And you were left scratching your head. You were like, hey, I just tried to do a cut extrude. Or I see this question in Reddit. How come I'm doing a cut extrude and the model's not cutting? It's not removing material. So if you've ever been in that spot, if you've ever done a cut extrude and the cut extrude doesn't work, give me a 1 in the chat. Just gonna rehydrate here a little bit. I know this stuff isn't that good for you. I'll cover up the label so you don't know what it is. It'll be a mystery as to what it is. But it's a little too sugary for me, to be honest. But just want to rehydrate a little bit this morning. All right, so I see a bunch of people. Yep, Varn, yep, Sandeep, you've run into this. Okay, Stefan. All right, awesome. I'm going to explain to you why that happened now, and I think it's going to make total sense. I am in a command here called cut extrude, and a cut extrude command exists on the solid body toolbar. Solid body commands are going to affect solid bodies, but why? Why is it only going to affect the solid body? Well, the answer is what the cut extrude command is actually doing is it's creating a surface boundary or surface region of a cylinder with 2 capped ends, just like what we created. And then it's doing a cut and using thicken and close volume and subtracting that volume of solid material. So we are bringing out the cylinder, capping both ends, and then doing a surface cut, remove, and then we end up with this region here. Well, when we go to attempt that command, the important qualifier there is that it is looking for any solid geometry that exists within that region. And this here is not solid geometry. This is surface geometry. So we're not able to cut, extrude, and remove any solid geometry because there's no solid geometry there. There's nothing there to remove. Surfaces are theoretic in nature. So when we hit the green check mark there, SolidWorks says, okay, I'll remove anything solid from within that region, but there's no solid over here, so it doesn't work. So as Vishank put in the chat, you got it exactly right, Vishank. If we go here to our extrude command again, or our circle command again in sketch mode, and then we go to create a not extrude, not cut extrude, but a trim. What we're doing is we're creating a surface that is extruding perpendicular to the sketch plane kind of indefinitely, and then we're using that surface to trim the geometry. But we don't have to create the surface. We can just do it with a trim. We're in sketch mode here, and we go trim surface, and it's now going to extrude that in this direction, and it's going to allow us to trim this geometry away. So trim is kind of like cut extrude when you're using it in sketch mode. It's going perpendicular to your sketch, and then it's projecting onto this geometry. It's also kind of like Spline, the way that it's projecting onto this geometry. And you can see here that in the toolbar, there's this option that says keep selection or remove selection. What does that mean exactly? Well, it means that when I click on this, do I want to remove these two items? So if I hit the green check mark there, you can see those two items get removed. Or, let me go back and clear this. Or if I change this to keep selection, if I click on this, do I want to keep this item? Now, I'll say in like 90 to 95% of the environments that you're going to find yourself in, it's going to be the same. You're going to get the same result. You can either choose to keep and pick here, or you can choose to remove and pick here. A lot of times it's just more convenient to pick one over the other. So if we look at this example of the rectangle, so here you can see the rectangle, and now I'm going to do a trim command. So I'll go here to trim, take that rectangle, turn it into a planar surface. And now I'm going to do the trim command. So I'm going to say trim surface, and I'm going to pick this guy here. Let's say I'm looking at it at an angle like this. Do I want to remove or keep this? It's just easier for me to pick that rectangle because I can't see down into the hole. It's just easier. And a lot of times that's it. It's just that simple. That's your motivation. But there are times when you get into complex trimming where you've got 3 or 4 surfaces all coming together where you actually will see a difference, and one solution maybe is not even available where the other one is. So there are fringe cases, but most of the time it's just about which is easier to select, which is more convenient. In our example here, you can see that we are using the keep selection option just because it's easier. I only have to pick one if I'm going to do keep selection. I don't have to pick 2. So that's an example of using trim with a sketch. Now here what I'm going to do is I'm going to go to my front plane, and I'm going to drag a plane out like so. And I'm going to hit the green check mark, and then I'm going to drag a plane out in this direction like so. And I'm going to hit the green check mark. And then I'm going to go onto this first plane here, and I'm going to begin a sketch and orient my view. And I'm going to create a sketch of a spline. And this spline is going to look like this. And then I'm going to go onto that plane that's in the back, and I'm going to begin a sketch, and I'm going to create another spline, and this spline is going to look like this. And then I'm going to do a surface. So I'm going to go here to surfaces, and I'm going to do a lofted surface. And you notice here, lofted surface looks almost identical to its solid counterpart. So I'm going to do a lofted surface that goes from this region to this region. So there you go. There you can see that lofted surface. I think that looks pretty good. And now I'm going to choose to trim. And this time when I go to choose to trim, I'm going to say that this lofted surface is my trim tool, and that I want to keep this lower region here of my surface body that I created earlier. So now what happens is the lofted surface is used to trim, and then that lower region is retained, and the upper region goes away. Now, what do I do with that lofted surface body when I'm done? Some people like to go into the command insert features, delete keep body, and then they pick on that extra surface body, and they hit the green check mark, and now that body goes away up here in the tree. So there were 2 bodies here a moment ago. Now there's only 1. In fact, there's actually a shortcut here. If you pick the name of the body here from the tree and then press delete on your keyboard, and then press delete on your keyboard, you can see that shortcuts you into that delete body command. So you could do it that way. You can get rid of it. Most of the time for me, I just hide it, but it just depends. A lot of this stuff gets very in the weeds as far as like what the situation demands, what would be more convenient. So you can either add it as a feature at the bottom where you're deleting that body, or you can just hide it. It has no surface, it has no mass, it doesn't matter to me. Just like we would hide planes. Here I'm going to go to the front plane, and I'm going to choose trim surface, and you can see here that now I'm going to use the front plane to trim this body. So you can use planes as trimming tools as well. That's pretty convenient. And now I'm going to finish up here by taking this body and performing a thicken command, and I'm going to thicken this into a solid, hit the green check mark. So now it's a solid, and then I'll do a solid fillet command, and I'll make a fillet here at 3 millimeters. I'll pick this one single edge, and then I'll come up and to the right and get all the other edges in one shot. Hit OK, and there we go. We got ourselves a face shield, or whatever it is. An overmold. Maybe this is an overmold for a thermos, something like that. The point is, you can see here that you can, just by learning these few couple of tricks here, you can take a cylinder and you can turn it into something that, you know, you might have looked at it first and been like, wow, that's way too complicated. There's no way I could draw something like that. You know, maybe the sidewall, instead of it being cylindrical, maybe it's lofted, and then from the lofted geometry, you know, you're getting this wall thickness. You got this lofted geometry, and then you're doing your trim to the lofted geometry. You know, whatever it is, you can see here that there's some really powerful tools that you can learn about just by learning about how some of these trim commands work. Trim, thicken, you know, surface extrude, surface loft, one face at a time. Yeah, turn it into the Iron Man mask, exactly. All right, so I think that's it for our, you know, first lesson here. Every solid is actually a group of surfaces. We talked about how when you're working with surfacing, if you can learn these kind of key tools, learn how to do extrude, revolve, sweep, and loft, which are tools that you probably already know, and learn how to do the filled surface command, learn how to do a planar surface, an offset surface, and a trim surface, you're going to be able to create a lot of really cool stuff. These are the key surfacing tools for beginner. And then, of course, the knit command. You know, whenever you're doing surfacing, you're going to need to learn how to use the knit command to knit those surfaces together into a solid. So you can see here, SolidWorks, obviously, they took a inspiration from one of my childhood heroes when it comes to the knit surface command. The knit surface command icon looks like this, but obviously, you know, that surface icon came from my main man, Mr. Fred Rogers. Those of you who are across the sea might not know who this guy is. Maybe you do. If you know who Mr. Rogers is, give me a 1 in the chat. This guy is the man. He ran a children's TV show over here in the States for a long time on public access. And you can see here that that is exactly where we got the SolidWorks knit surface icon from. When you're doing that knit surface command, you want to remember that you're looking for that new option that says create solid from enclosed volume. So create solid from enclosed volume. And you can see here that when it comes to create solid from enclosed volume, that's only going to show up when you have a, you know, completely watertight vessel. So if I go planar surface here, you can see that I can add a planar surface on the top. If I go, you know, planar surface or fill surface or something like this on the bottom, you can see I've got a fill surface on the bottom, and you can see that I go knit surface, knit these three together. And now when I go to the thicken command, I'm looking for that new option, create solid from enclosed volume. Once that's there, I'm good to go. And that is basically the common workflow that we go through. Now, one question that I got was that the knit surface command, can you just do a knit surface and a thicken all at once? This is a question I get all the time. So here I am in the knit surface command. Let me just roll back here. So how many, you know, what do we have in the tree? We've got 1, 2, 3 surface bodies. Really, really handy to get used to looking up there. So I can tell at a glance these haven't been knit yet. You know, can we go into the knit surface, and then can we also solidify that? This is this create solid option here. Can we solidify that all in one shot? Yes, you can. Do I do that personally? No, I don't. And the reason I don't do that actually kind of ties back, and there's a good example of it in this model here. When I'm doing complex trimming, a lot of times what I'll do is I'll take 1, 2, 3 surfaces and I'll knit them together, and then I'll use that as my trim tool. I'll use that to slice the top of the lid. So for me personally, when I do a knit command in the tree, that doesn't necessarily mean I'm solidifying. So for example, right here, you'll notice I didn't turn that into a solid after doing that knit. I knit those surfaces together because I'm anticipating using them for a trim. I knit these surfaces together here because I'm anticipating using them for a trim or for some other purpose. So I don't personally knit and solidify in one command. What I will often have in my feature tree is I'll have a feature that says knit all, and then I'll have a feature that says thicken that comes right after it. If you want to put them together, you can. It's totally cool. Like it's all good. No problem for me. But it's not what I do personally, and that's why, because a knit does not necessitate a thicken. I'd rather have them separated so at a glance I can look at the tree and I can understand what is being represented by the tree. So that's just me personally, and I hope that makes sense, and I probably should not have left that in the rollback state, and I'm going to close this. I'll probably open it up later, and we'll look at this some more. All right, guys, we're right on schedule here. We're actually a little bit more than halfway through the presentation, so we're right on schedule here, and we're gonna just keep on going, keep on talking about these basics of surfacing, and show some kind of real world examples. Like, this is something that I'm sure you have run into before. Every solid is actually a group of surfaces. But sometimes when you open up a file, especially an imported file, it's just surfaces. It's not a solid. And I've definitely been in this spot before, and I'm sure that a number of you who are watching have been in this spot. If you have been, give me a 5 in the chat. If you've ever opened up a model, if it came in as an IGES, like here you can see I'm working with an IGES. If you've ever been working with a model and it opened up and it came in as a surface instead of coming in as a solid, give me a 5 in the chat. I definitely have been there. So here you can see that this model came in. Now, because I have the bodies folder shown here, I can tell right away, and that's going to be useful. So you can see here that this thing came in. Maybe I downloaded this file. Maybe I got it from an online website, or got it from coworker, or they sent me a file. They sent me an IGES. So I see you guys in the chat here. Patrick, you've been here before. Barry, you've been here before. You bring this thing in, and it doesn't come in as a solid. It comes in as a solid. So now what? Or it comes in as a surface. So now what are we supposed to do? How are we supposed to use this in our designs? Well, we want to go through the same exact workflow. Create a watertight vessel and turn that watertight vessel into a solid. A bunch of people have had this. Varun, you've had this before. Avery, you've had this. Rashab, you've had this. Stefan, yeah. Chuck, you've had this before. Sandy, yeah, you guys have all had this. So you want to take this surface model and you want to turn it into a watertight vessel, and then you want to, after it's a watertight vessel, watertight surface, you want to thicken it. You want to thicken it into a solid. So step 1 needs to be, well, where the heck is the opening, right? I got this big model. How am I supposed to find the opening? Now, we know from the previous slide where the opening is. We know it's right here, but it's not always that obvious. So how do you find that opening? Well, you want to lean on a tool called Tools Check. It's also in the Evaluate toolbar. So Tools, Evaluate, Check, or here on the Evaluate toolbar, Check. And when you launch that command, Check, it's a great command when we use as surfacing users, when you get deep into this thing with lots of models that are maybe wrinkled, or there's model integrity concerns. We use this all the time. But one of the checks that it will check for by default is, where are the open surfaces? Are there any open surfaces? So I say Tools Check, and it says there's one open surface found. And when I click on it, look at that. It gives me an arrow. It shows me right where that problematic surface is, which is just awesome. Like, this is just such a nice time saver and so good to know about. So first, you figure out where those open surfaces are. Now, if you've got a model that comes in that's got a bunch of like bad geometry, like wrinkly geometry or whatever, then maybe what you need to do is you might need to do a delete face command as well. So you might need to go to Surfaces, delete face, find those faces that look bad, or sometimes I've been in spots before where you bring in a solid and the solid ends up like it like loops around. It kind of looks like it inverts a fillet. I've had that happen lots of times, like bringing in stuff from Rhino or from other CAD formats. So when you have a surface that's bad, sometimes what you have to do is delete that face. So you go to the surfacing toolbar and you go to the delete face command and you say, I just want to delete it. Delete that face and then perform the steps that we're about to show. So sometimes you have to delete the face. Sometimes it comes in and there's just a face missing and you don't know why. So first you find that face. And then what we want to do is we want to take that example of taking the blanket, right, and laying the blanket over the open geometry. So that's the example of using the fill surface. And you saw a moment ago, there's all kinds of extra stuff we can do with fill surface that we're not going to get into today, like when I dropped in that constraint curve, or there's options for how am I going to be connecting to this edge here? Is it just going to be just connect right to the edge straight, or do I want to enforce a degree of tangency to that existing edge so that I end up with a smooth result? Maybe this edge here, that would be really important. Coming off of this edge, I don't want it just to be a flat spot. I want it to be tangent to that edge. But in the case of what I'm doing here, and probably in the case of a lot of models you're working with, like if you're not manufacturing it, if you're just receiving it and you need it to be part of your assembly, then it probably doesn't matter and you can just leave everything as contact. You don't have to worry about, like, is it coming off of here perfectly smooth? Just lay the blanket over top, get the thing filled, and get the thing solidified. So we create a surface there. All right, that looks pretty good. I think we're ready to thicken this, right? So we click thicken, we pick our surface body. Hey, where's that option for create solid from enclosed volume? What did I miss? that option should be there. I'm pretty sure this thing is watertight. What did I miss? I forgot to knit. You got to remember, after you create that surface, you got to knit it back into the original full surface body. So we go knit surface, knit this to this. Maybe at this point you choose create solid. If you do, that's all good. I'm not going to do that. I'm going to hit the green check mark. Now I'm going to choose thicken. And now when I click on this surface body, hopefully I remember to, or hopefully I get that new check mark. Yep, I do. I click that check mark. Now SOLIDWORKS is going to try to take that watertight volume and fill it in with solid geometry. I hit the green check mark here. We look at this thing in section. Oh yeah, that looks awesome. Nice solid geometry all the way through. That's what we want. So when it comes to surface modeling, it's almost always those same steps. Okay, so you start out with your, surface geometry. You make your different surfaces, you patch them together. I just put notes here. I wasn't sure what you wanted to write, but you start out with your surfacing geometry. You take those surfaces, you put them together, you patch, you trim, you knit, and then you thicken all that into a solid. Or in the case of the face shield, what you do is you just make, one surface, you trim it up so it looks the way that you want it, and then you just add a thickness to it. Instead of trying to sweep that as a solid and then cut it as a solid. I mean, you always run into issues with stuff like that, right? When you're doing that face shield example that I showed here a little bit earlier, where we did, actually this is probably gonna be all screwed up now. When we did that surface loft example. So here's that surface loft. Let me take this and I'm gonna do a delete face. So I'm gonna delete the top and the bottom of that solid. That turns it into a surface. Here's my surface loft. And I'm gonna say that I wanna take that surface loft and I wanna do a trim with that surface loft. So here's my surface loft, here's my trim. And I'm gonna say keep selection, and I'll pick this region down here. And then I'm going to go to my front plane and trim, and I'm gonna say keep selection, keep this here. We always run into issues with what's happening at the wall thickness. So if I go to thicken here, and I say I want that to thicken to, say 0.1, to 1 millimeter, there's always that question of what's happening right here. What is happening with this thickness? Is it perpendicular to this edge? And where that question really becomes complicated is if we have this as a thin feature and then we try to do a loft cut through there, what's the loft cut gonna look like in the front view? It's not gonna look like this. It's just gonna be cutting straight through. You're not gonna see this extra edge here where it's wrapping around, but that extra edge is more realistic in the manufacturing world. So there's a lot of benefit to just drawing one surface and then thickening it to give yourself the final product. Just draw that one single surface. You don't have to worry about, okay, is this cut also perpendicular? Is this loft also perpendicular? Is this also, you don't have to worry about any of that now. You just make your one surface and then thicken that one surface into a solid at the end. Letter B. Surfaces have no thickness, have no volume. We've beat this up a lot. They're not going to affect your mass properties. They can just be hidden when you're done, or you could delete the body when you're done if you want. That's a quick one that we ripped through. So if you're continuing to take notes here, every solid is actually a group of surfaces. Surfaces have no thickness and have no volume. Surfaces are considered reference geometry. You're using surfaces to get to solid geometry, but you're not handing off a bunch of surfaces to the next person in line. At least not most of the time. There's always fringe cases, but most of the time, that's not what you're doing. Now, why work with surfaces? Surfaces allow you to create one face at a time. Solids force you to create all faces at once. So we've seen a couple examples of why work with surfaces so far. Like we saw how you could use a surface as a plane. That might be a spot to use surfaces. I wouldn't really consider that surface modeling, but it is a cool tool that you can use. You could use surfaces to fill a single face of a model that imported that had a problem. You could use a surface for that. You can use surfaces to patch certain regions of your models, like we did when we deleted the face on the top of the cylinder, and then we added a little spline up top, and then we did a fill surface to lay over the top. So you can add a single face at a time, and then you can patch that all together. But sometimes you run into certain models that are all curved, that don't have any straight edges on them. And I was trying to think of a good example of this, and one day I was standing around the office and I saw this. And for those of you who are ladies in the crowd, you may not have seen one of these before, but this is the top plumbing from a urinal in a men's restroom. And so what I said was, oh, wow, look at that shape. That would be a perfect shape to show with surfacing. Because to create a shape like that, how would you do that with solid geometry? It'd be pretty tough. You might be able to do it if you created a solid chunk of material, and then if you did like a sweep cut around the outside. But other than that, it would probably be pretty difficult. So I tricked one of my coworkers into going into the bathroom and taking some measurements for me. I didn't want to go in there. I didn't want to look like a weirdo in there with my, dial caliper taking measurements off of this thing. So I tricked one of my coworkers into going in there, getting these measurements for me, and then I took those measurements and I put the measurements here into a SOLIDWORKS model. So this is a SOLIDWORKS model here, and what I'm using with this SOLIDWORKS model is I'm using a little trick that I use a lot called sketch color. So this here is just a 2D sketch of the front view with all the dimensions. And then what I did was I did a right mouse button on that sketch and I went to sketch color. This is a trick that I use all the time, and I just picked a color that would really make that sketch pop. So instead of it being the default gray color, which is sometimes a little bit hard to see, I decided to go in here to sketch color and change it to something that would really pop. So like a red here. And then my second sketch is just a sketch of a line, just a green line, and you can see that's just representing the width of this thing. So now we're going to take that geometry, just two simple 2D sketches, and we're going to turn that geometry into this really cool model here that has basically, no straight edges on it. It has a planar face here for now, but it really has no straight edges on it. Yeah, and PJ's Toolbox says urinal measurements are what working with students is for. Yeah, exactly. Yeah, you never want to be the guy standing there at the urinal holding any kind of measuring device. That's just gonna look weird all around. You don't want that. All right, so let's get into how we would make this in SOLIDWORKS. We start out with these two just simple 2D sketches, and one of them isn't even really necessary, just helping me with the width. So what I'm going to do now is I'm going to start out by creating a new plane. So I go here to reference geometry plane, and when I go to create this new plane, I'm going to pick this curve, and then I'm going to pick the end point of this curve. That's how you make a new plane perpendicular to a curve, and that is how you should always be starting your sweep profiles. Your sweep path should always be first. Your sweep profile should always be second. That's just a general rule, best practice in the world of sweeps. So this will be called profile plane 1. And now I'm going to go here to this plane. I'm going to begin a sketch. I'm going to orient my view, and I'm going to create a 3-point arc here. I'll say that I want this point to be vertical to my layout sketch. I'll say that I want this point to be vertical to my layout sketch. A lot of these shortcuts that I'm using here are in my Power Moves videos. So like knowing how to hold control and let go of control. Go here horizontally. A lot of times when I'm teaching essentials, I tell people that we learn all about relationships and letting go of control. And they think I'm weird. All right, and now I'm going to go here and I'm going to say that I want this depth here for the arc to be maybe 4 millimeters. Okay, cool. Now I've got that nice curved shape there. So I'm going to exit that sketch, and now I'm going to perform a sweep surface. So a swept surface, starting here at this curve and going along this path. Swept surface. Boom. Done. Looks great. No volume, right? No thickness, just a swept surface. All right, so far so good. Now I'm going to go to the right plane here, and the front plane here, and I'm going to begin a sketch, and that's going to be a sketch of this arc. So I'm just going to take this arc here, and I'm going to do a convert entities. I'm going to exit that sketch, and then I'm going to go here to the front plane. I'm going to hold down on the control key on my keyboard. I'm going to drag, and I'm going to drag that to this point here in my layout sketch, and click on that point, and then right mouse button to finish that command. It's a good shortcut there for adding new planes. And now on this new surface here, I'm going to begin a sketch. I'm going to create an arc again. So we'll create an arc here, very similar to the arc we created before. And we're going to say that we want that arc to be pierced to this curve here. I got a video on pierce coming out soon, but pierce is another one that's really important to understand when you're working with the wonderful world of sweeps and lofts and, ultimately surfaces. So, and then finally, I'm going to create a dimension here. Now, this is a video that I did create, I think just a couple weeks ago, where you can create a dimension that goes maybe from this point to this arc here. And if you hold shift, you'll get a shortcut to the peak of that arc. But sometimes you have to have a line to do it. So it's just worth noting here that I've been in spots like this before where it's better with a line. Hold shift, and now you see I get the peak of that arc instead of getting the center point. Default behavior would be dimension to the center point, but if I hold shift when I do that, then I can get the peak of that arc for that dimension. So I'll make that 3 millimeters so that it's got a little bit more curvature there on the front, a little bit of weird curvature. Now, creating one face at a time. You know, surfaces allow you to create one face at a time. Why is that so important? Why is that so valuable? Well, we can really reap the benefit of that here in this example because we're going to create a loft, and that loft is going to go from this curve to this curve and then over to a third curve. When we go to create that loft here, we pick this first curve, we pick the second curve here, you'll notice that there's a gap between these two surfaces. And what does that mean? That means that we are not going to be able to knit those surfaces. Remember, knit isn't going to work if the two edges aren't right on top of one another. Because we're making one face at a time, a lot of times in surfacing, what we're able to do is we're able to use the edge from the previous feature, or the previous face, as a guide curve for the current feature. So in other words, we can say that we want this edge here to be the guide curve of this loft, and that's going to pull the loft up to that edge as we're creating it. So now this is going to be a guide curve. And now the nature of loft with guide curve is that's also going to pull the edge up down here on the bottom. And now this is going to be a guide curve as well. So when we finish that loft, we don't have that gap because that gap would not be good. So the ability to create your geometry one face at a time, once again paying off here. I'm going to pick this plane, hold control, left mouse button and drag. I'm going to pick this point here to make a new plane parallel to the first one at that point. And then normally I would probably, you know, properly create another sketch and pierce it. But for sake of time, I'm just going to say that I want to convert the geometry from this sketch onto that new one. I know this thing is symmetric, so I actually probably would just model half of it and mirror it depending on how complicated it gets downstream. So now what I'm going to do is I'm going to perform a lofted surface command. Lofted surface, I'm going to pick this, this, and this. And I'm going to then choose guide curves by choosing the edge of the previous face and the edge of the previous face. And there we go. That looks awesome, right? So now we can see that we're ready to create a planar face on each end, knit all the surfaces together, and then thicken it into a solid. So we're going to go over here to our planar surface command, and we've got an option in SOLIDWORKS surfacing called select loop or select open loop. So I can right mouse button here and I can say select loop or select open loop. Open loop is kind of like a hole. But you'll notice when I go to do that, it doesn't give me the edge of this surface here. And the reason why is because these two surfaces are part of two separate surface bodies. So another shortcut that I will often use when I'm doing fill or when I'm doing planar surface is I'll just do a quick knit, and I'll knit these two surfaces together. And why am I doing that? For one simple reason, just to make it easier for me to select open loop here. That's it, no other reason. Just knitting them together to make the selection a little bit easier. So now when I go to planar surface here, I can right mouse button, select open loop. And now you see I get all those edges and I can quickly drop a planar surface on there. Just saves me having to go click, 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 click all the way around since I know I'm going to be doing it on the back as well. So planar surface or fill surface, I mean, you could do either. In this spot, it's probably going to be almost identical geometry. Select open loop, fill surface there. If I pick that face, yeah, this is a little shortcut that you can use in SOLIDWORKS. If you pick a face and this icon shows up, it means the face is planar. If you pick a face here, that icon doesn't show up. That's the begin a new sketch command. So if I pick that face and that little sketch icon shows up, that's telling me that face is planar. That's a quick little trick that I use when I'm not sure. I'm like, hey, look at this face. It looks like it's flat, but is it? Oh, nope, the sketch icon didn't show up. It's not planar. Look at this one. It looks like it's flat. Yeah, it's flat. Sketch icon shows up. Just a little quick trick that you can use to quickly determine, is it planar? Is it planar or is it not? All right, we go knit surface. We knit these guys together as well. Knit these three guys together here. And then we go thicken. And if this thing is watertight, when we pick thicken, a new option shows up over here. Yep, create solid from enclosed volume. Boom, nice and clean. And we have ourselves a beautiful, solid body. Pretty cool, right? Pretty cool stuff. Yeah, guide curve is so useful when you're doing those lofts, and using that previous surface is just awesome for guide curves. Awesome. All right, guys, listen, we got about 30 minutes left. I'm going to take a quick bio break. I got to go hit the men's room real quick. I'll throw a timer up here. I don't think it's going to be the full 5 minutes. It's going to probably be less than this full 5 minutes, but just give me a minute. Enjoy the background music. I'll crank up the background music a little bit for you here, and I'll be right back. I don't know if it's just because we're drawing this part, the urinal part, or if it was from all the hydration or what. I was squirming. I'm going to go back and watch the recording of this, and you're going to see me squirming. Alright, we're going to bring this guy down. We'll get started here in like... Let's say we'll get started at the 2 o'clock mark. 2-minute mark. That'll give people a chance to get back in. Give me a chance to become TooTallToby again, yeah. Alright, here we go. So welcome back, everybody. Thanks a lot for that quick break. I'm sure that when I watch the recording, I'm going to be seeing myself squirming. Alright, let's get back into this here. So there we go. There is our model. Nice and solid. And again, just continuing to go through that same process. You know, that's what the process is all about. It's all about going through and taking models, creating one face at a time, and then turning those models into a solid. Now, I got a couple other quick examples for you here before we come down the home stretch. And one example is a challenge like this. Like maybe you're talking to the manufacturing team, the machining team in your company, and somebody says, hey, I want you to just create this shape here. And sweeping this as a solid, sweeping this triangle as a solid, it's a little bit challenging. And the reason it's challenging is kind of nuanced. It's because of the sketch relationships fighting each other as you're trying to create the sweep. And what I mean is if I go in here to the sweep command and I choose to sweep this triangle along this path, I say, okay, that looks good. I take that over to the manufacturing team and they say, that's not quite what we wanted. What we really wanted was we wanted this to continue all the way along this edge and this to curve down. And then you say, oh, okay, so you need this to be a guide curve. Okay, that's no problem. So we go in here and we go edit feature and we go into guide curves and then we pick this edge here and it's not working, right? And why isn't it working? Well, it's really two things that are fighting each other. One is that you're trying to take this, really the big one is that you're trying to take this triangle here and you're trying to take this line and squish it down to nothing. And SOLIDWORKS doesn't really know how to handle that line when it becomes 0. So if I made a tiny little height adjustment here on this end, then it would work, but then we would have a little step there, and that's not what we want either. So when you're getting into your geometry and you're able to simplify your geometry to work with surfacing, those types of errors don't come up nearly as often. You know, if I don't have this line here and I don't have this line here, now I can perform a surface sweep. So I go surface sweep here and I can sweep this surface along this path. And then I can go down here to guide curves and I can say that I want this to be the guide curve. And look at that. It works. It doesn't give me any errors. It looks awesome. You know, and I can show that to the manufacturing team, but then they're going to say, yeah, but you still have this big pocket back here. You know, they might not even see that surface because of that big pocket there. So this is where I like to introduce a really useful command in SolidWorks that's called replace face. And what replace face lets you do is it lets you take geometry that's in a solid and replace one or more faces with geometry that's derived from a surface, and it lets you actually both add and remove geometry in one single command. So I'm going to create this as just a simple surface extrude, but you could imagine this could be a complicated loft, or it could even be multiple surfaces that you've knit and trimmed together. So maybe you've got loft curvature and you've got revolve curvature. You've got all kinds of different curvature on this surface. Again, I'm just doing it as a surface extrude here just for the sake of time, but you could certainly make this a very complicated surface with multiple surfaces coming together, being knit and being trimmed, and then leaving you with this result. And now what you can do is go to the surfacing toolbar and choose replace face. And you can say, I want to get rid of this face of the solid and I want to replace it with this crazy, swoopy, lofty shape that I made in the surface. And look at that. SolidWorks both adds and removes geometry from the solid in order to match up with that surface that you created. It extends these surfaces on the side, it trims the surfaces on the side, and then it caps it off with that new surface that you created and trims that into place too. So this is a super powerful command, and it really ties into our lesson of making one face at a time. Yeah, we've made this one face, but now how do we turn that into a solid? You know, one thing that we could do is we could create a planar surface here and grab this perimeter. We could create a planar surface down here just by doing an offset surface, and we could create a planar surface here of the triangle. Then we could knit all those planar surfaces together, solid, and merge back into this main solid here. And that would all absolutely work. In fact, that's how we did it in the old days. But now we can get in here, we can just say replace face. I don't want this face of the solid anymore. I want to use this surface instead. Right mouse button, that finishes that command. And then we could either hide or maybe delete this surface body using the delete body command. And now that surface body is gone, and we're able to give the manufacturing team exactly what they want. So, you know, you could get there with solid geometry, but it would be a lot more tricky. And it's a lot easier when you don't have those extra unnecessary lines in your solid features. So if we apply that same capability here to this model, the urinal model, what if we wanted this front face to be curved? Oh man, that adds a whole new level of complexity, right? Because now we have to figure out what that original sweep is going to look like, and how is it going to actually sweep along a 3D curved edge. Like, this is going to be so difficult, right? No, not anymore. Not now that we know about replace face. Now we could simply get in here, create our shape, our curved shape on the front. Let's say it's a circle that maybe looks something like this. So we'll just do, you know, one of these. I'm just kind of eyeballing it up here. And then what we'll do is we'll make it spherical. So I'll create my center line here where the center of that circle is. I'll go to surfaces, revolved surface, and I'm going to make this a revolved surface using mid-plane and using 90 degrees. So there's my revolved surface. I think that looks pretty good. You can see that it's both, you know, beyond our original surface, and it's also intersecting with our original surface a little bit. And now I'm going to go to replace face, and I'm going to say that I want to get rid of this face of the solid, and I want to replace it with this face of the surface. And I'm going to hit the green check mark and hide that surface body, and look at that. We've got ourselves some curvature. Is that so cool or what? That is just like, to me, I love this stuff. This is where I'm like, holy crap, surfaces are just so awesome. Like, it's like, oh man, I can't believe we can get away with that so easily. You know, this curve here, this 3D curve, it's pretty difficult to visualize. It's pretty difficult to figure out what would be going on there, and then to sweep along that as well. You know, it's going to be a little bit of a challenge, but here using replace face, we can just get exactly what we want. So if you ever were challenged to create, something like this, like a stool, that might be a way that you would do it. You would create it as a solid, extrude it up with draft, or extrude it straight and then put draft on the appropriate sides, and then create that surface geometry up top using maybe 5 or 6 different surfaces, knit them together, and then just do a replace face, and you're good to go. Yeah, it's I appreciate the feedback in the chat, Patrick and Avery, and Tambora. It's so awesome when you learn about some of these commands, because you're like, holy crap, I was doing that the long way around for so long. So, all right, awesome. Yep, thanks, Eric. Appreciate the thumbs up. So every solid is actually a group of surfaces. Surfaces have no thickness, have no volume. Surfaces are considered reference geometry. Surfaces allow you to create one face at a time, and solids force you to create all faces at once. And we use the replace face example. And now we get into the final of these topics, which is that surfaces and curves are partners. So you've got all these different kinds of curves here that are available, and you want to learn how to leverage each of these. And we're not going to have time today to get into all of these, but we will take a look at a couple. One of them is the split face command, and this was actually something else I saw on Reddit. Somebody asked a question, can you do a setback chamfer the same way you can do a setback fillet when you've got 3 different chamfer values coming together in one spot? So you can see in this example, we've got our 3 different chamfer values coming together in one spot. And this is a cool example, but it also kind of serves as a cautionary tale. And I actually, it's funny, last night when I was laying in bed, I was thinking about this, and I was like, oh, I could have done that differently and done it way easier. But sometimes when you work with surfaces a lot, you kind of get into the zone. And depending on the curvature of this model, it might not have been an option. So here you can see that what I want to do is I want to create a nice chamfer in the corner that matches up to all 3 of these. And so using surfaces, what we could do is we could select this face, begin a sketch a line, bring a line from here down to here, and then take this planar face and split it up into 2 different faces where that line is. And the way that we do that is we use the command curve split line. And when you use the command curve split line, you can see that we can split up this face into 2 separate faces. It creates a new edge. It doesn't create any new volume or mass or anything. It just takes that face and it splits it into 2. So we can repeat that process here. You can see that I can go to the line command here, and then we're going to go to curve split line. It's also on the surfacing toolbar. It's the same command though. And then same thing here. We can go to curve. Whoops. We can go to curve split line, and we can split that face as well. And so now what you can see is that we've got ourselves these 3 different faces here that we can delete. So we can go delete face and delete these 1, 2, 3 different faces because we split them up. And when we delete face, you can see that we're left now with a surface body. We've got these blue edges here that tell us that this is a surface body. So surface body, this is still surface body here, but this just means that the 2 faces are merging properly. This means that there's an open gap. So that's open surface edge, closed surface edge. And now we can go to the fill surface command. We can do filled surface, and we can take this 1, 2, 3 edges there, fill them in by laying that blanket over top of that opening, and then we could do a knit surface, knit this together, and then we could do a thicken this into a solid. Boom. There you go. Chamfer at the corner using 3 different chamfer values and always updating properly. Good stuff, right? And so this is a cool example, and it's really easy, and I looked at it and I was like, oh, I know exactly how I would do that. And then I thought about it for a while, and I was like, you know what? I think I went a little overboard on that one, because I think what I probably could have done is I probably could have just done a plane, right? I could have just done a reference geometry plane and done 1, 2, 3 points, and then just use that, right? That would have got me the same thing. Would it have? I think it would have, right? So if I roll down here to this final result, yeah, they're coplanar. So I could have just done it that way. I just kind of overthought it, and then I overthought it, and then I realized afterwards I was like, oh no, I should have done this differently. Yeah, and that's kind of similar. And Eric's saying, what if you just did a 3D sketch? That's a good solution too. You could do a 3D sketch, 1, 2, 3 lines there. Fill that as a surface, and then do what's called cut with surface. So yeah, I like that too, Eric. That's a great suggestion. So we could go here to sketch. We could go to 3D sketch. Take this point, this point, this point, this point, and then do a surface fill with that. So we go exit sketch. It's selected. We do fill surface. picks that boundary. And now we've got that surface sitting in there. And then we could do cut with surface and hit the green check mark. And then SOLIDWORKS uses that surface to cut it away. Yeah, I like that too. So it's a little, I realized after I created this, it was actually last night when I was laying in bed, I was like, oh, you know what, I probably could have just done that with a plane. But there are other spots where the geometry is more complicated, and it is nice to be able to fill it in there. And the other thing is, you want to remember that fill is not limited to, to just those lay it on as a flat planar surface. Maybe I wanted to create some curvature there. So maybe I choose to make it tangent to this face and tangent to this face and tangent to this face, or some other, weird solution that's going on there to create that patch. So you want to make sure that you learn about your curves, and the big ones are fit spline and projected curve. So fit spline is one of my favorite commands in the software. I love it. I wish I could make sweaters that say I love fit splines. Like, it's just such a good command. And what fit spline lets you do is it lets you take a scenario like this where we're going to create a sweep along this path here, and it lets you take the geometry from that path and merge it together into a single spline. So I can go here to the front plane, begin a sketch, and normally, we could select this geometry and we could perform what's called a convert entities. And so we end up with arc, all arcs there. But another thing that we can do is we can use what's called fit spline. Tools, spline tools, spline tools, fit spline. You can also search for commands up here. So if you type in fit, that will help you find that command. A lot of times I use that little command search thing as like a temporary icon almost. So I've got fit spline up there now. Anytime I want to use it, I can just go up there and click on it there. And now I'm going to do convert entities again, but instead of just converting, this is actually going to convert and turn this into a single spline. Now by default, the spline wants to come all the way around and it wants to close itself off. So you have to remember to turn off this option here, closed spline. Otherwise you get this extra shape here. So I turn off that closed spline, I hit the green check mark, and now what I'm left with is a single spline that is tracing over that geometry. Fit spline. I love this command. I could talk about this command forever. I'm not gonna. I'm just giving you the highlights. But what this means is that now when I go to perform that sweep, I don't have a bunch of extra edges in the sweep. I end up with just one single. So there it is. I'm picking the original geometry. And now here, I'll pick the spline, and you can see that it all ends up being one face. Now, when you're working with a lot of surfacing and doing a lot of trimming, you don't want multiple surfaces to be coming together and creating little tiny faces. And that's what happens a lot, and that's where this is really beneficial, merging multiple faces together. It's also really useful if you're doing simulation. It's useful not to have a lot of small faces, but that's a whole different topic. So that's one example of fit spline. Another example of where fit spline is super beneficial is that it can automate the jumping of gaps. So for example, I can create a fit spline that goes from here to here, and the fit spline will actually jump that gap. So you can do it in the same sketch, or you can do it in a different sketch. Usually I do an underlying sketch that's fully constrained, and then I do the fit spline over top of it. So I do fit spline here, and I'm going to say I'm going to go from this line to this line, and you can see that the fit spline can actually jump that gap with a tangent spline entity. Now the reason that's super beneficial is because it means that you can automate, or at least significantly simplify, the transition into a helical path. So here you can see that I've got a helix that's defining the path of a sweep, and it's a variable pitch helix, so it's starting out looking like it's a little more compressed, and then it's going up. And then what I wanted to do was I wanted to create a transition running into that helix. So the way that transition was created was that I created here's the helix. Here is a plane that I created. I'll just make a new plane. I'll show it to you from the whole thing. So here is the front plane. I'm going to hold control and drag. I'm going to make a new plane out here at this point. And then I'm going to start a new sketch on that new plane, and I'm going to create a new line that is a little bit away from that helix. So maybe I'll come down with the center line a little bit. I'll come over with the center line a little bit, and then I'll create a solid line. There we go. Now I'm going to go to a 3D sketch. So sketch, 3D sketch. And I'm going to choose to use the fit spline command, and I'm going to choose to create a fit spline that goes from this helix, not closed, and then to this line here. And you can see that the fit spline actually jumps that gap and merges those entities together, giving me what's ideally a smooth path. Now you can see there that that one's got a little bit of a wrinkle. All right, no problem. The cool thing about Spline is that it does dynamically update. So as I, move this out and move this guy over here like this, you can see that the Spline updates and gives me a smoother and smoother transition. Let's keep modifying that. Let's just say we don't need quite so much of a gap in the vertical. There we go. Now we're getting that nice smooth transition. So Spline is just awesome. It's just one of my favorite little tricks that I keep in my back pocket to use when I'm working with these types of transitions. And you can see there, now I've got that nice smooth transition from the solid line, jumping that gap, and then jumping over to the Spline. And so now I could go to a sweep command. And in the new versions of the software, you don't even need to have a profile. You can just do a circular path, and then I can pick that geometry, and we can see what that smooth transition would look like in the actual sweep. So I know that that's something that I've struggled with. Yeah, and Eric, sounds like maybe that's something you've struggled with too. Yeah, I know that's something I've struggled with, and it definitely helps in those spots. Now, when it comes to the Spline command, the other thing that it can do that's pretty cool is it can automate the creation of radiused corners for sweeping. So what I mean there is, if I've got a bit of geometry that looks like this, it goes from here to here to here, and we'll say that that is fully defined. So I'll just right mouse button, fully defined, little shortcut there. Little trickery there. And then I'm going to go to front plane, begin a sketch, and I'm going to create a Spline. I'm going to go from this curve to this curve to this curve. What's going to happen here is that SolidWorks, SolidWorks can't make this as a spline if it doesn't have radii in the corner. Well, you can use this little slider here to control how closely you are matching the original geometry. So this is going to be a spline. It's going to have a radius in the corner. It has to. It can't be, it has to have some type of a smoothing blend in the corner. But how much of a smoothing blend do you want there? You can use this little slider here to control that. So where that becomes really, really helpful is when you've got crazy 3D sketch paths that you're creating, like in the case of this lid here, and you want to fill in the transition of those crazy 3D sketch paths with some type of a spline. So if we roll back to let's say this region here, you can see that what I did was I created a transition that goes from here to here. So it's going from a 3D sketch running up this edge to a 3D sketch that's over here. Well, that geometry, when I created it, it was sharp. It looked like this. It was a sharp corner. And I was able to use Spline to come around that corner and to blend that transition around a corner in a 3D sketch. So I didn't have to get in there and, like, even though you can fill it in 3D sketches, sometimes when you're filleting around a corner, you can lose some of the integrity, or it can be hard to lock it down to the desired angle. This has helped me out with that a ton in the past, and it's another good tool to remember, is that when you're doing Spline, it will create curves in the corners, and you can actually control to a degree what those curves are. One thing to note is that it will not be exactly one-to-one. Even if you are using a radius, it still won't be exactly one-to-one because it's a spline versus a radius. A radius has curvature immediately. It's flat, and then it has curvature, and then it's flat again. But a spline starts out flat and then gets a little bit of curvature, then a little more, then a little more, then a little more, then a little less, then a little less, then a little less, and then it's flat again. So even if you have a radius here that you're tracing over, it's still going to be off by a little bit. So if that's important, maybe you want to just stick with a radius and not switch over to a Spline. So I love Spline. There you go. Now you guys know that I love it. The other one that's really important to learn about is what's called projected curve. And projected curve is just amazing in SolidWorks. What projected curve lets you do is it lets you take a 2D sketch, like this sketch here, and it lets you take a second 2D sketch, like I'm going to go to the top plane here, and I'm going to create a second 2D sketch that looks like this. And it lets you project those two 2D sketches together. So here's what the top plane looks like. Here's what the front plane looks like, just so that we have a frame of reference here. So there's what those two planes look like. And if you imagine we were to take a surface and extrude the surface this way, and we were to take a surface and extrude the surface this way, wherever those two surfaces come together, that's where your projected curve is going to land. So you don't have to do it. Like, you can do it this way, actually. You can do what's called an intersection curve, and you can pull those two together. But instead, what I'm going to do is I'm going to go here to curves, projected curve, and I'm going to take this sketch and project them together, leaving me with a shape like this, a 3D curve passing through space. And then I could take that 3D curve and use that to create a sweep path. So here what I would do is I would start a new 3D sketch. I would say I want that to be a sweep path. And then I would go into my sweep command, and I would say sweep a wire. This is what it reminds me of most often, is a wire. Sweep a wire along that path. Look at that, 3D all the way through 3D space. So if you're looking at this from the top and you're routing a wire through your device, now all you need to do is move this over to here. Okay, I'm just going to route this wire through the device, and then from the front view, it needs to go up. It needs to constantly be going up to get through, navigate through this device. And now we get out of this thing, and there's our 3D sketch. That's so cool, or what? Yeah, Chuck says projected curves are awesome. Yes, they are indeed. Neil says, wow, yeah, the fit spline and projected curves, these are absolutely partners with the wonderful world of surfacing. So how are they partners? Why are they partners? Well, we've seen a couple examples so far, but I think we're pretty much winding down to our final example, which is the mouse. The mouse is kind of like a rite of passage when it comes to the use of surfacing. So we're going to take everything we learned in basics of surfacing, and we're going to take all of that and we're going to turn that into an example of creating the mouse. And we're going to show you how to create some of the surfaces for the mouse. We're going to show you some extra tips and tricks. We're probably going to be done, probably in about 15 minutes. We'll probably finish about 10 minutes after the hour. But what's cool here is that you're going to see, water slide. I like that, Deborah. Yeah, if you're designing water slides, your life just got a lot easier. We're going to see here that as we're going through and showing this mouse, it's all coming back to these basics. Every solid is actually a group of surfaces. Surfaces have no thickness, have no volume. Surfaces are considered reference geometry. Surfaces let you create one face at a time, where solids force you to create all faces at once. And surfaces and curves are partners. And you want to remember that same workflow. That workflow that we showed is the workflow that we use over and over again in surface modeling. You start out with your individual faces, you knit them together into a watertight surface, and then you solidify that. So with all that in mind, let's take a look at the mouse example. Now, the mouse example, like a lot of projects that I've worked on, starts out with some images. So you're going to take pictures and you're going to take measurements off of those pictures. There's so many projects that I've worked on that's how those projects start. The skateboard, am I going to sit there and measure a bunch of different points on the skateboard and use that to figure out what the perimeter of the deck should look like? No, I'm just going to take a picture of the deck. So here you can see my first sketch is a layout showing what the approximate location of information should be, and then I'm going to take a picture of the deck. Now, when you take a picture of something and you try to bring that picture in, you should know that it's almost never going to line up perfectly. Here you can see where the holes are from the mounting hardware, and they're clearly not in line with the holes for the, from the picture. But it's close. It's close enough. It's close enough to get done what you need it for that job. The wonderful thing about engineering is that we're always talking about tolerance. What is the tolerance for this project? And it's always based on what you're trying to accomplish. In this case, I was trying to put together a really cool data set. So did it have to be perfect? No, it just needed to look cool. And I wanted to capture, I wanted somebody to look at it and be like, that looks right. A lot of times when people look at skateboards, it doesn't look right for two reasons. One of those reasons is the skateboard doesn't go straight along this edge. It curves out a little bit and then curves back in. The other reason is that a skateboard bends in two different directions. So you've got the bend on the skateboard in this direction here where the nose is, but there's also a curve going in this direction of the skateboard. The skateboard isn't flat on the bottom, it's curved on the bottom as well. And so you end up with almost a wrinkle here right near where the wheelbase is. So I wanted to capture all that. I wanted it to look real, and so I used a picture to help guide my process. This example of the growler here. What's the very first element of this growler? The very first element is a series of pictures. So here you can see that I'm going to be again, just like with the skateboard example, if I roll back to the beginning, I created some layout geometry, and then here's an image to help guide what's the actual profile of this handle? What's the side of this bottle actually look like? You use images to help out with those kind of weird scenarios that are difficult to capture with the measuring tools that I have, here in my home office. I don't have a CMM or anything, so I'm not going to be able to capture it that way. And I use this idea of taking pictures all the time. So what it usually looks like is I take a kind of like a layout perimeter, and I use that layout perimeter sketch to help me get started. So just like with the skateboard here, you know, I started out with a sketch that gave me the perimeter of the skateboard, and then I bring that picture in and I lay that picture within that perimeter. And the way that you bring in a picture is you use the command tools, sketch picture, tools, sketch picture. And then once you bring the picture in, you can resize it by dragging it here like this. Or there's a tool here called Enable Sketch Tool. It's on by default. It's this little blue arrow here. And what this lets you do is it lets you pick one point of your image by grabbing this little magenta dot, and then pick another point of your image by grabbing the arrow. Where's the arrow? I lost the arrow here, maybe because I turned it off. And then when you, I'll show you with the mouse. And then when you grab that arrow and you drag it, you're able to resize the image based on that arrow. So in the case of the mouse, what I would do is I would start out with a layout just like this, and then I would drop the image of the mouse on top of that layout. Yeah, common engineering. Yeah, close enough. Can't see it from my eye. I like that. So we're going to bring in the images, and we're going to add those images into SolidWorks. And so we need to know what the measurement of the mouse is. So we're going to say here that the mouse is 42 millimeters high by 116 millimeters long. All right, so let's jump into SolidWorks here. Let's create a new image or a new part. This part is going to be in millimeters. So I'm just going to go down here to the corner. I missed the click there for that one. So I'm just going to go down here in the corner and pick the millimeters template here. And then we're going to go front plane, begin a sketch, orient our view. And we're going to say that this is 42 millimeters by 114 millimeters. So 42 by 114. And by the way, shout out to Chuck. Chuck, you when I showed the video of how to do this rectangle, I think you were the one who commented and said, it always puts the dimensions in wrong. It always does YX instead of XY. My whole SolidWorks career, that has never bothered me, never once. And ever since I read that comment, every time I make a rectangle, I type in the wrong number first. And I always think of you, and I always laugh, and I thank you so much for that comment. I love the comments in the different YouTube videos, and that one, like, it cracks me up every time. Every time I do it now, I'm like, 114 by 42, and then I'm like, oh, I went the wrong direction. I'm like, oh, Chuck. Yeah, it's like so funny. So so that's my sketch of my dimensions here, 42 by 114, which should be 116. Let me change that, 116. So I measure the physical device, and then I drop in a rectangle there. Maybe what I do is I go in here and I say sketch color, and then I go here to red, make it red there to make it a little easier to see. Now I'm going to call that one front view layout, and I sometimes will also have the image here in the I'll sometimes have the image here in the its own in the same sketch as the layout, and sometimes I have the image in a separate sketch. More often than not, I have it in a separate sketch. You know, you guys I think have seen my style enough here that you know that I don't care how many features are in the tree. I care about how easy I can navigate my models. So a lot of times that means I just make an extra feature, and I'm good with that. So we'll go in here to this image of the mouse from the front, and we'll bring this image in. And then here you can see that I can take this this is called the scale tool, enable scale tool. I can take the little magenta dot there, drop it here. You can take the magenta dot here, drop it here, let it go. And then I get a dimension dialog box. And this is saying, okay, you position that arrow at the start point and the end point. What do you want that dimension to be? I'll make the sketch that size for you. So it's just resizing the sketch for me. So I'll make it 116, enter, and now you can see that the sketch is 116, you know, from the start of that arrow to the end of that arrow. It's just like a little shortcut tool you can use. Usually I use it just to get me kind of close, and then I turn it off, and then I get in here and I start resizing the sketch using these little arrows up here in the corner. If the option is on, then you can't use those little arrows in the corner. You'll get a message. Oh, it's on now, and I'm still able to use those. Usually you'll get a little message that says you can't scale it. You have to uncheck that option because the scale tool was on. But in this case, you can see I'm able to scale it. So I'm going to scale this. Maybe I'll turn off aspect ratio if I took the pictures bad. This is a horrible picture that I took here. This is not a good example of a picture because of how much curvature I'm getting, you know, on the bottom. I should have taken it more at a 90-degree angle, and I should have taken it standing back a little bit as well. I talk about that in my SolidWorks live design video on the SolidWorks YouTube channel. Tips and tricks for taking pictures. It's right at the beginning of that video, but I should have thought a little bit more about this, the way that I took this picture. I was young when I took this picture, so I'm still learning. All right, so we're going to bring this down to about here. What we're going to try to do is we're going to try to create this curve here that we're looking at in this kind of light blue color, we're going to try and create that curve. So it's the curve that's running along the rear edge of this, where it goes from the hard plastic to the soft plastic. So we're going to just get this thing into position. Pretty good. Looks like it's pretty good there. We're like basically touching off on the peak. Again, we're really using this more for guidance rather than for exact tracing. So as long as it's pretty good, you're good. The other thing that I do is I go here to this full image. And when I go to the full image, a lot of times I'll kind of dial back the transparency a little bit of the full image. That just makes it easy to see through in case there's something behind that mouse. All right, and then I'll call this image. I always call these ones image in front view, and that way I can quickly hide and show. If I don't want to see it, hide it, show it. Now I'm going to go top plane, begin a sketch, and basically rinse and repeat. So top plane, begin a sketch, rinse and repeat. We're going to go tools, sketch picture, and we're going to go here to our image of the top of the mouse. We're going to bring that in. Same thing here. We could kind of get it close, say. We want that to be, 116 or whatever it is, and then we can bring this guy together. Now, with this image, I'm actually going to be relying on a downstream feature to help me size this image properly. So I'm just going to kind of get it in here close, but I know it's not going to be perfect right now, and that's okay. I'll turn off the aspect ratio, I'll turn off the scaling tool. I'll kind of get it close here, but I'm going to wait until I get my first curve in and then see how that first curve lines up with this image. So I'll dial back the transparency again a little bit, and I'll call this one image, exit the sketch, call this one image, top view, and now I'm going to save that model. And to save the model, I always use Control S because my hand is always right here, and then we'll save that model into our surfacing live stream, and we'll call this mouse complete. I spelled it wrong. And then I'm going to continue on with this design. So what I'm going to be doing is I'm going to be making one face at a time. And the face that I'm going to be making, the face I'm going to be starting out with here is going to be this face here, this little hard plastic face. And we're going to be using the tools that we've learned so far about surfacing, like let's make one face at a time, and let's use projected curves to create our layout. So we're going to... can you lock the position of the picture so it doesn't move, resize in space? That's a good question, Current Peak RC. I think that it may move if you have Instant 3D on. No, it doesn't. Yeah, I mean, if you double click on it, that's how you get in to edit it. And as long as you don't do that, you won't move it. I don't know if you can lock it beyond that. But like here, you see if I go to drag it, it doesn't move it. I don't know if having Instant 3D turned on would change that. No, it doesn't move it. So yeah, you just got to try not to double click on it. That's the only thing I can really say. Just don't double click on it and then you won't be able to move it. But I don't think there's a lock. That might be a good enhancement to suggest to the development team. So now we need to create this curve. And as we talked about a moment ago, projected curves are going to be some of your best friends in the SOLIDWORKS surfacing environment. So I'm going to go here to front plane, begin a sketch, and I'm going to create a spline. Now, one of the things that we talk about when it comes to working with splines, especially when we're getting people acclimated, is if you look at this spline here, the way the icon looks, and you wanted to draw that, you might, start out by drawing something like this. Click, 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 click. And you really don't want to do that because you're going to end up with a lot of wrinkling in that spline. The spline's going to be very hard to control. So what a lot of people don't know about when it comes to splines is that there are these things at the end of a spline called a spline handle. And you can grab these things. They have 3 handles on them. They have a diamond, they have a triangle, and they have a little dot here. And by grabbing those little tools, you can change the angle of tangency influence, you can change the magnitude of tangency influence, or you can change both. So even though when I started out with this spline, I just created a straight line, you can see that I'm able to use this to basically create that icon for the spline command, just by using that 2-point spline. And most of the time, I start out with just a 2-point spline. If you need an additional point, you can always right mouse button here and say insert spline point. But the more of these points you have, the more things are going to end up getting wrinkly as you're dragging things around, the more you're going to end up with like weird results with curvature, and it's just not going to look good. It's going to reflect lighting weird, which is bad in the cosmetic industry, which when you're doing surface modeling, that's what you're going for. You want your surfaces to be nice and smooth. So in the case of this mouse here, when I go to create my 2D spline, I'm going to create that spline starting out here at the bottom of that curve that's on the kind of rear of the model, and then going up here to the top of that curve that's on the rear of the model. And then I'm going to click on that spline, and I'm going to grab the spline handle. I'm just going to start dragging it until I can get this spline handle to more or less follow that curvature. So I'm just using the picture to help me eyeball this up, kind of drag this like so. Yeah, that looks pretty good. I think that'll work. I That gets me pretty close to what I'm looking for there. Yeah, I like that. I can get on board with that. Maybe what you would do is you would make this one vertical, and that's going to help you with making this model symmetric. You know, when you go to mirror this thing, you're going to be able to make it symmetric. Maybe you would go in and you would fully define this thing to kind of lock it down, just so that it's not moving all around at the end point. So you can lock this down here. Let's say I make that 32.8 for the height, and I make it, I'm just making it whatever it currently is, and I'm dimensioning it off of that layout sketch that I created earlier. This is another spot where you can see that it can be beneficial to have your layout sketch separate, because now I can hide that image, but I can still see the red boundary box for the layout sketch, so I can still get in there and add dimensions to this thing. You can also define things like what is the angle of tangency influence. So even though the line is black and even though it says fully defined here, I still have some blue geometry that I can just grab and drag around. So you can actually get in here even more detailed. You can click on this guy here, this guy down here, and define the angle of tangency influence, and you can define the magnitude of tangency influence. And that's going to completely lock things down. Now, I don't really do it that often, but when I do this, it's mainly because I want to be able to get in here and say, I just want to bump that out a little bit, and I want it to be empirical so that I can go back to what I had before. So I'll say, like, how about 60? How about 66? I think 54 looked better. I've got like an actual anchor point that I can go back to. But most of the time when you're surface modeling, it's kind of like the Wild West. Like, most of the time you're just leaving stuff. You're leaving stuff underdefined. You're just trying to make it look good. If it looks good, it is good. That kind of thing. So now I'm going to take that. I'll call that curve from front. And then I will right mouse button, I'll say sketch color, and I'll make that something that'll really pop again, just to make it a little bit easier to see. And now I'm going to go top plane, and I'm actually going to take my top image and drag it down in the tree, just to make it a little easier to see. And I'm going to edit that sketch, because I want to make sure that when I'm looking at the top image, that the curve for the hard plastic is lining up in the right spot. I'm not that concerned with the, the remaining geometry, like where the rest of the mouse is on this thing. But I do want to make sure that that curve is kind of lined up, just so that I get kind of the same result. So maybe I make that a little bit shorter in that direction, and maybe I could take a look here at how this point is lining up on my sketch. So it looks like it's probably pretty close. It's pretty much close enough to lining up with that front corner. So yeah, I think that looks pretty good. And again, this is something where if you're trying to match it exactly with the original mouse or get it close, like I did the same process when I created this this thing that goes over top of my camera, thing goes over top of my webcam here. So I took pictures of the webcam. Well, in that spot, it's really important that this is pretty close, because I wanted it to be able to not fall off when I had the webcam in a bag. I wanted it to double as a lens protector. So it's really important that those dimensions are right. So I'm going to take a lot more care. With this one, I just took pictures of the mouse to get it close, just so that I could draw up an example here. It wasn't as important to me. So now I'm going to go to my top plane, and I'm going to begin a sketch, and I'm going to be referencing this curve that I created on the front plane. So I'm going to go top plane, begin a sketch, and I'm going to create another spline here. This is going to be a spline that goes from this front corner point over here to this point. And I'm going to be referencing the points from that original sketch. So for example, this is going to be vertical, so that that point of the spline is at the same, so the projected curve starts at the same spot. You don't have to do that. You saw that earlier, but it's something that, it's going to be useful if they are at the same spot. And so I'll do the same thing here. I'll take this point and this point, and I'll just make those two coincident, just so that they're right on top of one another. And now let's take a look at this thing from a top view. Okay, we can see what this is going to look like. I'll click on this spline. I'll grab the spline handle. I'll move the spline handle over like this. I'll move the spline handle over like this. Again, if I make that vertical, it may help with mirroring. It doesn't. I say it may help because it doesn't guarantee that it's going to mirror, smooth without a seam. There's a whole rest of the surface that I have to consider. But at least it'll help get me in the right direction. And there you go. I mean, that's pretty easy, right? 2D sketches. Now, what are we going to do with those 2D sketches? We're going to take them. Let me change the color of this one. So I'll call this one curve from top. And so now I'm going to take this 2D sketch. I'm going to say sketch color. Make that like a blue color. I'm going to take those 2D sketches, and I'm going to choose curves, projected curve. And I'm going to project this curve into this curve. And there we go. Cool, right? We got ourselves that really nice guide for our sweep or for our loft or whatever it is we're trying to do. In this case, I'll go to the front plane. I'll begin a sketch. I will create a spline. So I'll just go to my spline command. This spline is going to go from that same location from my previous design down to this point here, down at the very front corner of the mouse. And I'll take that point and just make sure it's at the same location, maybe using pierce or maybe using coincident to the underlying geometry. You can do it either way. So I could take this underlying point here and make those two coincident. And then what I'll do is I'll click on this spline and I will drag these spline handles in order to get the desired curvature. You can see here, I mean, look, I mean, you think of a mouse, you think a mouse is like, oh man, it's going to be so curvy. How am I going to do this? Well, most of the stuff you can do with just 2-point splines, at least with this mouse. I know this is kind of an older mouse, but still, it's a pretty cool little example. Again, you can take these handles and apply angles or maybe make it vertical. So if I click on this handle here, I can make it vertical, and maybe that gets me a little bit more of the result that I'm looking for. A little bit of manipulation there to get it right. I'm going to say that that's good. And that is going to be my loft guide 2. So this projected curve is loft guide 1. And then this second curve here is loft guide 2. And I always, after I do these, I always do a quick Control S just to save the model. My hands are already there doing the renaming, so I may as well do it. Now I'm going to go to the top plane, begin a sketch, orient my view, and I'm going to create another spline here. This spline is going to go from my guide to my guide. So these are going to be pierced. You want to always pierce when you're working with guide curves. So this is my guide here at the center, and that point, that's going to be pierced. And this is my guide here, and that's going to be pierced. And now we go back to our top view. We click on that line, that spline, excuse me, and we take this spline here and drag it over. Maybe I'll make that vertical, and that pretty much just worked out, right? And that's expected. Like, it should just work out because when you're doing sweeping and lofting, a lot of times you're using your guides to lay out the geometry. Now, here's the one little trick to this thing. So far, everything has been 2D sketches, right? We've got our loft guide here, which is a 2D sketch. I'll make that a different color so it kind of pops out. We've got our hide this layout here. We've got our projected curve, which is just 2D sketches, and we've got our loft profile here, which is a 2D sketch as well. So everything is just 2D sketches, everything we're doing here. We are going to do one 3D sketch, but don't worry, it's just going to be a point. So that's the entire 3D sketch right there. It's just that point, and I'm just going to take that point and drag it here to the end point of my guides. And that way, that's going to be where my loft is going to terminate. So that's going to be my loft profile 2. So I'm ending at a point, and you can see here that what we can do is we can say that we want our surfaces to be a lofted surface that goes from this profile here, loft profile 1, to this profile here, loft profile 2, and it just shoots that right into that point, just shoots it right down into that single point for our loft. And so now we can go to our guide curves and we can say we want to pick this as a guide curve here, that inner 2D sketch that we created, and we want this as a guide curve here, that outer projected curve that came from the two 2D sketches, and that gives us a loft. And wow, that's looking pretty good. That's a pretty good start to our mouse. There's one thing about this I don't really like. It's got like it looks like it's almost too flat in this direction. So something that's been in SOLIDWORKS for a long time is you can inject a loft profile midstream in a loft. And so what I mean by that is I'm going to say that I'm going to identify that flat area that I don't like as being right about here, let's say 50 millimeters back from the front plane. And so I'm going to take that plane and just make sure that it exists before the surface loft. Now I can put it anywhere in the tree because the only dependency is the front plane, right? So I can put this anywhere. So I'll just put it here, like just before the loft, and I'll call that new loft plane. So it does have to be before the loft, and now I can right mouse button on the loft feature in the tree, and I can say add loft section. And so what add loft section lets me do is it lets me pick that plane. I say use selected plane here, and SOLIDWORKS will create a new curve intersecting between the plane that I selected and the existing loft. So I hit the green check mark, and now when I examine the loft, it has the starting profile, it has the ending profile, and it's got this new injected loft profile. I'll call it injected loft profile. And now I can edit the sketch of that injected loft profile, and wow, it's already a simple, 2-point spline, and I can just take this point here and pierce it to this guide. so that I can, make sure that it always stays aligned with that guide. And now if I look at this thing here from this view dead on, I can take these spline profiles and just drag them, and that's going to give me that additional curvature that I want. So maybe I'll make that one horizontal, vertical, Control Z, make that one vertical. There we go. And then this one I could just kind of eyeball it up, make it look good. And now when I exit that, oh yeah, that's money right there. We don't want that flat spot that was there before. We want it to be nice and curved. And that gives you, the start of your mouse. Now, where would we go from here? Well, surfacing allows you to create one face at a time. So where I would probably go is I would hide these guys here. And I would go, maybe I would actually keep the top view showing. And I would go top plane, begin a sketch, orient my view. And I would create a line that goes like this. And I would create a spline that goes like this. It would come all the way up here to this point. And then I would take that spline and I would move it, manipulate it into place so that it looks like the bottom of the mouse. Maybe make it vertical. And then I would take this curve here, which is our loft profile, and convert it. So what we're doing is we're using the edges of the previous face. This is that whole discussion of why, creating geometry with surfaces is so powerful, because you can do one face at a time. We'll make that a planar surface on the bottom. Now we don't need to see this image anymore. We can hide that so you can see there's our two surfaces. And now we could go to our front plane here, begin a sketch, orient our view, and we could say that we want on the front plane, we want to utilize the image from the front again. So we'll call up the front image again, and we want to utilize a curve that's looking like that front image. Now again, I didn't do a good job of taking these images, so things aren't quite lining up as well as they usually do. So don't get too hung up on that, on thinking about that. But here we can see what that image would look like, and we could always adjust that plane on the top to get things looking a little bit better. We could even go to this existing edge and take this guy here and apply some type of a relationship between them. So let's say we go to this existing edge of the existing model here, or even go back to that earlier guide, right? The loft guide here. So we could say show that, and then we could take that loft guide and take this guy and give them a tangency relationship or a curvature continuous relationship. All right, so that's going to be our new loft profile. Just like we did before, we could also create a 3D sketch. So we could create a 3D sketch here that is going to be of a point, and we'll put that point exactly here in the corner so that it lines up with our other geometry. And then we could do a lofted surface once again. So we go lofted surface from here to here, and we say that this is going to be a guide curve and that this is going to be a guide curve. And now we've got half of our mouse as surfaces. And so we could do a mirror. So we go here to front plane, and we could do a mirror, and we could mirror those bodies. You want to do mirror bodies command when you're working with multiple solid bodies. And then we could get in here and we could do a maybe a bit of final cleanup. Like you can see here that there's clearly not tangency between these two, and the reason why there's not tangency between these between this geometry here is it's a little bit nuanced, but it has to do with what was happening with that loft and the guide curve for that loft. I actually would probably do that with a boundary, and that way I could enforce tangency across the side here. But look, if you end up in a spot like this, what can you do to resolve it? One thing you can do using the tools that we've already learned about is you could go top plane, begin a sketch, and then you could create a sketch of a rectangle that looks something like this. And then you could go surfaces, trim, and you could say, I want to remove these little problematic areas. So we're just going to remove those surfaces running along the top. And then what can you do here? You could do a fill surface, right? You could go here to filled surface. You could say, I want to make a fill surface that goes from here to here, and from here to here. And that you want to utilize, maybe this is a boundary as well. Actually, I probably should have knit those first. Let's knit these real quick so that we get those hard edges. We talked about this a little bit earlier in the presentation. Knit those first, and then we'll do a fill surface. Now we can even do the that option for select open loop, make it a little bit easier to select those surfaces for the fill surface. And then as we're going through and we're looking at these edges, we could say, I don't want that one to be contact, I want it to be tangent. And we could say, I don't want this one to be contact, I want it to be tangent. And you could do the same thing with the other two that are across from it. I don't want this to be contact, I want it to be tangent. Let's go down to this one, make that tangent. And I don't want this to be contact, I want it to be tangent. So the difference between contact and tangent is it's declaring how it is gonna create that blend. Oh crap, I picked the wrong one, sorry guys. So we'll make that contact. Actually, I'll leave the other ones not contact just so that you can see the difference. So the difference here you can see is the way that the blend takes place. So here you can see as it blends across here, it's blending across smooth and tangent, where this one is not. This one is just coming kind of like straight off. So you can see the difference there. So you could always get in and create that additional geometry to finish out the mouse. And then what would we do? We would knit this geometry all together. We would do a thicken. We would say create solid from enclosed volume. And now we've got ourselves the mouse. A little bit of a lumpy mouse, I know, in this example, but there's a lot of ways that you could smooth out that region where they're merging together. But ultimately, I just wanted you to kind of see how we bring this all together. Pretty cool stuff, right, guys? Pretty cool stuff. So I hope that you guys like that. That's going to pretty much bring us to our final conclusion. If you guys like that, give me a 7, lucky number 7 in the chat. If I left you, a little disappointed, give me a 2 in the chat. So 7 if you liked it. Give me a number 7 in the chat if you guys like this. But you can see here that what we do is we go through, we take our pictures, we crop and edit those pictures, we bring those pictures into SOLIDWORKS, we create a framework using guide curves, and then we loft or we sweep along those guide curves. And you want to remember that using fit spline and using projected curves and splines, it's going to be so helpful. And that's going to pretty much bring us to the end. You can see here my final thoughts are we generally create a watertight vessel, then thicken it into a solid. We're able to create one face at a time, very important. You want to remember that surfaces are reference geometry. You are going to be using them for things like creating the layout for your solid geometry, but you don't typically hand off those surfaces as your final result. And you want to remember that surfaces and curves are partners. I see a bunch of 7s in there, so I appreciate that. That's awesome. If you guys, are successful in viewing this presentation, then the next time somebody sends you a surface model, instead of looking like this, you will hopefully look like this. You'll be happy. You'll be like, it's all good. I got no problems. I know exactly how to handle surfaces. If you do have any other questions, please let me know. I hope that you enjoyed this format. I really enjoy this presentation, and I've worked on this presentation for a long time, so I wanted to take my time going through and presenting this to you today. I hope that it does the topic justice and it gets you in the right direction. Remember, if you want to look up some super heavy-duty surfacing tutorials, look for somebody like Andrew Lowe or Ed Eaton. Those two guys are, definitely at the top of the game when it comes to super complex surfacing. And as you can see, even in these simple examples, things get a little bit nuanced. But yeah, it's all good. And Avery, I love it, man. Avery says, just build it one face at a time. No need to rush. Yeah, exactly. We just take our time going through this. I really hope that you guys enjoyed this. And I know that we went pretty long here. It looks like we're at like 2.5 hours now. So I'm running out of steam a little bit. I'm sure that you are as well. But I'm liking this format. I'm glad that we got to go through it at this pace because I like to take my time. I like to make sure that, that everything comes across crystal clear. So thank you all so much for tuning in. Please feel free to put any comments below. Please share this with other people. Anybody you know who's interested in working with surfacing, share that with them. And if anybody has any questions, let me know if you have any questions. I'll try to answer them in the chat. Some of them might even be over my head, like Vishank is asking about optimized surface option. I'm not sure. I haven't used that enough to know and give you a practical example of the nuances. Maybe that's something that we can ask Andrew. Andrew's going to be on my live stream in 2 weeks. So, Vishank, if you can tune into that, or if you can leave a comment on that one once I post it, I'll try to remember to ask him. Or you can even leave a comment in here in this one, and I'll try to remember to ask him in 2 weeks. And he'll, I'm sure, be able to give us a good answer to that. Okay, awesome. You guys, thank you so much. Thank you so much for all the feedback. I really appreciate everybody being in here. I think I'm going to end it now, and I look forward to seeing everybody in the next one, and the next one, and the next one, and the next one. And we'll try to get a lot more cool content like this out there to everybody. Be sure to like and subscribe, and be sure to share this with other people so that they can learn some of these great tips and tricks too. And that's it. I hope you guys have a great Saturday. I hope you guys have a great rest of your weekend. Bye-bye.